This podcast is brought to you by PC component retailer and boutique builder Silvernight PCs. Use offer code BrokenSilicon to get 6% off everything on their website. And it is also brought to you by healthy and delicious Vite Ramen. And it is also brought to you by CDKeyOffer.com that gets you great deals on Windows keys and other products. You can find links in the description and the proper offer codes for all of these sponsors, and we'll talk about them later. But for now, let's just get on with the show. Welcome to Broken Silicon, a gaming hardware podcast. I am your host, Tom, and today I'm joined by somebody that, once again, it's his third time coming on. You're quickly becoming a fan favorite, and actually, I have to say, I have a couple other guests I was throwing around having on this week, and then someone in the Moore's Law's Dead Discord said, you know, you guys seem really tired at the end of the last podcast, which was like a 3-hour episode covering everything over the past month because we were on vacation. And Sapphire Rapids was near the end. And he said, your takes on Sapphire Rapids didn't seem wrong, but they seemed very surface level. I wish you could have someone on like Wendell to get into it in a little more depth. And I just said, done. And here you are. So please introduce yourself.
Hello, I'm your friendly neighborhood computer janitor. I don't know. I'm just some random internet bozo. I don't have any special insight. I make silly YouTube videos and I work on software and sort of, plumbing type things, software infrastructure. I find some of it really interesting. I write tutorials. I work on Linux. That's about it. I don't know what to tell you. Sapphire Rapids. I've got a Sapphire Rapids system. I got the big twin 2-node system from Supermicro that has it's not the highest end Sapphire Rapids processors, but it is the sweetest spot in my opinion in terms of price, performance, clock speed, and all of the stuff. And you look at the specs and it's like, oh, this is kind of pedestrian. And it's like,
well, how many cores is it per socket?
I think it's 44 cores per socket.
Only 44 cores. Yeah. What a peasant build.
Yeah, no, it's like, oh, it's not 96 cores per socket. It's 88 processors per node. And DDR5, PCIe 5, blah blah blah, 12 NVMe. And it's really fast. It uses a lot of power, but it's really fast, and I've really had a lot of fun playing with it, and it has some of the stuff in it that goes fast, like with one API and one DNN and all of that. Those are the beginnings of the accelerators, but there are even more accelerators and crazy stuff coming with Xeon Max and blah blah blah. But a lot of that is really it's surprising how difficult to access some of that stuff is, given the ambition of one API to be basically ubiquitous for developers, because a lot of the Intel's one API, basically, if you just use that, you automatically will get a lot of this really cool stuff to make math go fast. And then it's like, well, some of it is not there.
Well, so you actually mentioned it, and I like this question, and it's on something you said. So let me just get this out of the way first. Max Eliza writes in and says, hi, Tom, and hi, Wendell. I love your work. Wendell, you've often described yourself as a computer janitor, but what does that look like in practice? What would be a typical work assignment or contract for you? I get the impression that tech companies hire you to implement, profile, and optimize complex workflows involving multiple software and hardware components, including having you apply patches to open source components to enable or optimize the customer's use case. How accurate is this perception I've stated, and how often do these patches get upstreamed? How does one break into the computer janitor biz as well if you have the time?
I don't know. That's a much more nice description. It sounds awesome, and the reality is probably not that. I do occasionally get to work for startup companies, or I get to work on a large, interesting project. Those are a lot of fun. It usually pays pretty good, and is usually something really interesting. But most of the time, what do you think of when you think of a janitor? It's like, well, there's a toilet that's clogged up, and somebody flushed something they weren't supposed to, and you got to figure out its play. What did they do? It's basically that. It's like, oh, look, we're working on a database today. Oh, did you add some indexes? Oh, what are indexes? Yeah, that's not good. It's like, oh, we want to make this website go fast, and it's like, okay, in what context? Oh, this number's low. This number should be bigger, and it's like, well, but you're doing it wrong. Like, is it my job to explain Google Analytics to you? Do you not know how to use Google? Okay, well, I guess. So it's not really super glamorous. I have gotten to work on a couple of things. One of the most fun things that I did was I get to work on a system that had code in it from Grace Hopper. So that was fun. And I got to find some bugs in that. And that was, it didn't really end super well, but I had a good time on it. Tried to save some, taxpayers some money, and successfully showed some ways to save taxpayer money, but no one was interested in actually saving some taxpayers money. But
there's definitely an off-subject route I could go down on that note. But so, yeah, you consult basically many of these companies, Nvidia, AMD, Intel, and I'm sure tons of their suppliers and partners, they come to you with like a small part of a thing they're working on to either help them optimize it, or if there's an issue, could you maybe help them figure it out? But it's very ad hoc, lots of different things.
Yeah, every now and then. It's mostly, most of the work I do is very, very pedestrian. But occasionally I do get to work for a startup company or somebody that's got something interesting going on, and I get to figure stuff out, which is also interesting. But when I'm sometimes I'm in the more pedestrian meetings, and it's like, hey guys, I've got a suggestion. Why don't we do this? And when they inevitably don't listen to that, it's like, well, okay, but I did sort of work on this thing for some other company that was, a Fortune 500, but it's cool. If we can do your thing, it's fine.
Yeah. I do wonder, like, how much people understand, like, just, the average gamer or enthusiast online, like how many smaller groups, single people who are consulting companies are helping out all different types of things. Like, I mean, even when it comes to me, like getting information and stuff, and like who's giving input on things. It's not just all AMD at Intel, all people at AMD, all people at Intel, all people at Nvidia. There's dozens of smaller companies helping these products launch and contributing to maybe one IP block on a design, one piece of the software. Yeah. There's a lot more that goes into these products than just like these 200 people at AMD on this one team or something.
Yeah, I really enjoy that aspect of it, and getting access, getting to access to some of the people on the product side has been really interesting, from like the YouTuber, like, let's figure it out. Cause I don't know. A lot of the time I don't know. And a lot of the time I like to be able to ask those questions, like, why is this the way that it is? And can you tell me, architecturally why this choice was made, or why this or why that? Which really helps cut through a lot of the time, purchasing. Because by the time you're filtering to, we're going to buy $5 million worth of stuff, and my little part of it, like, it doesn't even really influence the purchase decision. It's basically just like, is it going to be able to flush? If the answer is yes, that's basically all the say so that you get.
On the subject of say so, every now and then I will get a message from like a Moore's Law's Dead patron, or someone will email me who watches my YouTube videos and says, can you ask your AMD contacts to add this feature to RDNA 4? And I'll just say, no, I cannot. They don't listen to Wendell half the time. No, some guy who sometimes talks to their engineers is not going to spark an idea.
The only features that everybody's really tired of me asking for at Intel and AMD is, can we get SRIOV? Can we get some software that lets us share a GPU among containers? Can we get some? And there, I finally am getting some. After almost a decade, I'm finally getting some. Well, yeah, that's probably not a bad idea. We should probably look into that. And it's like the technology in CPUs since Socket 1366 Nihilum to be able to run virtualized compute workloads moved at a blistering pace compared to, I would like to run para-virtualized workloads in a GPU, and they look at you like you have 4 heads. It's like, what? What is this crazy? Yes, I just want to be able to run 2 operating systems on 1 GPU. Why is this so insane? I know, that's the, there is a certain naivete in asking that question, but there's also not when you're talking about how they design those things these days with the compute cores and the memory and the partitioning and what we have in the enterprise and blah blah blah. But
well, so let me try to start off. I try to keep most of the stuff I talk about is more gaming focused, and so to try to keep much of the community listening probably on the hook early. You did recently do an i9-13900KS review, and I did want to touch on it because I really enjoyed it. There will be a link in the description. I hope people check it out. But let's just throw it back to you then right away. Like, how would you summarize the i9-13900KS?
It is one of the most incremental releases that we've seen from Intel in a long time. Because moving from 11th to 12th generation was genuinely breathtaking.
Oh yeah.
Moving from 10th to 11th generation set a new definition for what an incremental release was. And now moving from the 13900K to the KS, it's even more or less incremental.
Because sometimes it doesn't even outperform the K.
Yeah.
Right. In some of those benchmarks.
Now, what's disappointing is I've got three 13900Ks, and the real difference, the real thing they seem to be binning was not the cores, but the IMC, the memory controller. Because I got the insanely fast G-Skill memory kit, and I think the KS is probably the only CPU that I have that is going to reliably be able to go past to DDR5-7200.
Mm-hmm.
And when we have a GPU that's faster than the 4090, if making it go fast at 1080p is your thing, then DDR5, 8000 or whatever is probably going to be achievable on the KS where it's not really achievable on the K. But that's the nicest thing I can say about the KS. It's hot. It uses a lot of power. It's basically impossible to cool. And it's not worth the cost differential. As far as that goes, you can get almost the same gaming performance out of the i7. The i7 is probably a smarter buy.
Now I'm curious here. You have 3 13900Ks. Not KSs.
Yep.
Do they all hit 6600 megahertz? Is there's one that has trouble getting above 6200? I'm wondering if you've done that testing, because just to give some background, I have an Alder Lake. I had an Alder Lake i5. I now have a Raptor Lake i7 in my benchmarking rig for just if I test a random GPU on the side. And I have to say that especially with Alder Lake, the performance of the memory controller was all over the place, especially when it comes to DDR4 support. And I've seen there are so many armchair generals online arguing, oh, well, you can do this, you can do that. And it's I'm aware some Alder Lake CPUs can hit 4,000 megahertz DDR4. I've also run into quite a few that can't even get above 3,000. Say what you will about Zen 3 and Zen 4. They all hit a certain speed. They all always do.
Yeah, it is a huge mess. I had my favorite Alder Lake CPU was probably the 12400 when it was around $100. And it's not out yet, but I've got a video where I'm covering the 13500, which, by the way, the 13500, it's not even Raptor Lake Silicon. They're just rebadging the i7, which
well, it's because they my understanding and people who've listened to this is one of those things I throw out there every now and then, every other episode, is with Alder Lake, Intel seems to have thought if they caught up to AMD even remotely, their mindshare would make them retake the market. Alder Lake sold well, but it did not sell as well as they thought it would. And so they just have so much There was a smaller die in Raptor Lake they were going to use for these parts, but they have so much leftover Alder Lake parts that they're just going to rebrand them because they've made too many. It's
shocking though, because the system agent, so the 13500, Intel has owned gold themselves. I was not super impressed with the 7600X from AMD, for example. At $300, okay, now we get the non-X CPUs. That closes the gap a lot more. But that $100-ish 12400, which you can only get the 12400 for $100 for a very brief window, and it was like 130. And now it's closer to 200 where the 13500 is. And at $250, if you tell me it's oh, you're getting an Alder Lake i7 for $250, okay, that's that seems like that's pretty good. But that's also the kind of thing shareholders want to know. So like whenever I get the random shareholder that wanders in, they're like, let me know if any of these things are happening, and rebadging products is one of those things. And it's like, yeah, that's a red flag that shareholders seem to look for. I don't know. I'm not a day trader. I just answer technical questions. But in terms of like the stock and the performance and all of the other stuff, I think Intel's really owned gold themselves with the 13500, because even though it has those things, the system agent voltage is locked, and that's related to what you were saying earlier about the memory controller and the memory performance and everything else. And I don't think that the 13500, like the B clock overclocking, where you could accidentally do the B clock overclocking, that's a lot more locked down now too in 13th gen. They were able to fix that. But it's frustrating because those were the things that made those CPUs sort of the French case edge buy. Like if you wanted to be that person that finds like the most optimal deal in terms of compute per dollar, it's been curtailed to an extent that you just sort of play right into AMD's hands. And AMD's got a tough hill that you're still trying to climb in terms of performance per dollar, because AM5 is new, and because there are still minor teething issues, and because, you know, the CPUs that are out for AM5 are still relatively high end. So, you know, you can't get that DDR4 board with cheap DDR4 memory. It doesn't make sense for any Raptor Lake part that I've seen. And, you know, like the 12400, in a lot of cases, the non-K CPUs for Alder Lake seemed like they had a better IMC than the K parts, the i7 and the i9. And I always just assumed that was because they had been binning for the KS since day one. Every K that could possibly have a good IMC, those were all plucked from the line and shuttled off into, this is a potential KS territory.
But yeah, I mean, that's a thing that really annoys me when people like bring up, oh, well, you know, the i9-13900KS, this was a take I saw once AMD announced the X3D models. I saw not a lot, but a handful of people on the same day in my comments on YouTube say, well, once 8,000 megahertz DDR5 comes out, Raptor Lake will match the X3D anyways in gaming. And I'm like, well, first of all, number one, you're talking about like $400 RAM kits. So I don't know how all of a sudden you guys, these Intel fanboys, were constantly arguing Zen 4's RAM was too expensive. All of a sudden now it's okay to bring up 8,000 megahertz RAM for a 2% gain in performance over like 60.
Only at 1080p.
Oh yeah, and if you're a coil wine enthusiast, excellent. Which that's a thing I noticed testing the 4090 and a bunch of high end stuff recently. Is, man, coil wine's an issue now. But yeah, I mean, when I look at the DDR5 argument for Raptor Lake as well, it's not just the cost of the RAM that all of a sudden is okay for Intel to have. It's also like, I don't know that all of these chips are going to hit that. And like the difference in gaming performance between a 7700X and a 7950X is quite literally like zero.
Yeah.
But the difference in gaming performance between the i5-13600K and the i9-13900K is actually quite large, especially if one of them has, and it's usually the i5, a worse memory controller. And then if you were to put DDR5 with that i5, now it's actually losing by quite a bit.
Yeah.
And all of these arguments go out the window, and it just seems like it's a generation of like double arguments. It's like, well, the DDR4 support makes it cheaper, and it's but you can't say and it's good at gaming then, because
it makes it cheaper,
loses.
but you can't actually use it.
and all of this is leading me towards like, I understand that Zen 4 didn't sell. It certainly didn't sell as well as AMD wanted it to at first, and I do find the pricing on Zen 4 weird because it's a new platform, and you'd think if there was a time to be generous once before they take more market share, it's now, because get people on AM5. But I think they've fixed the pricing issue. The 7950X is now $600. The 7900X is $450. The 7600X is $250, and the 7600 is $230. Do you think there's a chance Intel's in trouble again with desktop market share this year? Because I know Raptor Lake outsold Zen 4 and during the holiday season, but what outsold both of them combined was Zen 3 on bargain sales. So yeah. I think AMD's just gotten rid of their Zen 3 stock. Now Zen 4 is cheaper. And like in the notes here I have, if they price the 7950 X3D at $700 and the 7700 X3D or 7800 X3D at $400 and so on and so forth, I don't really know how Intel competes with this lineup because we know their margins are so thin, right?
I really hope that AMD marketing for the 7000 X3D covers the memory aspect, because I don't know that I don't know this is true, but I expect this to be true. That if you noticed on the 5800 X3D systems, it didn't really matter about the memory speed anymore because the cache was just gargantuan. Yeah. It's like, oh, you want to run 3200? All right. And I did that so that I could run a 5800 X3D system with 64 gigs of memory, because you could get 64 gigs. I think it was 3200, might have been 2933, and it made zero difference in gaming performance of 1440p and higher. And I think we're going to see that play out again with the X3D. I think all of those cheap memory kits, like Micro Center and everywhere else, has like the 5600 kits.
Well, it's now actually 6000 free with it. But
yeah. Oh yeah. Okay. So you get the free 6000 Expo kit, or it's, they're on fire sale. I got a Corsair Dominator 64 gigabyte kit that was 5600, and I think it was $120 a DIM, $130 a DIM.
Yeah, that is getting close to I have 37, 33 megahertz DDR4. Yeah. It's getting close to high-end DDR4 pricing already.
Yeah.
If not cheaper than some of the crazier DDR4 kits.
And it's like, oh, you aren't running the Expo profile or whatever. I mean, I could dial in. I mean, I could do my own timings and probably get there. But the cache is really going to eliminate any sort of gaming performance differences with that. And so if you're looking at total platform cost, then AMD would be right to say, hey, this is a platform that's going to cost less, assuming the motherboard pricing parity also approaches that, which it is. We're seeing lower cost AM5 boards, and I have a feeling we're going to see some deliberate lower cost AM5 board launches with the when the X3D CPUs launch. And then at that point, it's like, especially with Intel making missteps with the 12500, they should never have locked a B clock, because nobody really does that anyway. I mean, really, what do they accomplish by locking the system agent voltage? I mean, come on.
And again, remember, all of these non-X SKUs from AMD, all of them can be overclocked. All of them can have the TDP set higher. I think they're on average 1% worse or something than the X models. It's
not even. It just depends on what you're doing. And the 7600, honestly, the 7600 and the 7900 for the low power home server and the power user home server, those are incredible CPUs to use for that. 7900 is a 12 core, enthusiast computer science college student that's not going to break the bank, upgradable AM5, blah, blah, blah. I think it's a really, 12 cores. If it wasn't so close in price to the 7900X, it would be a no-brainer. And I think in another month or two...
The 7900X actually went below the price of the 7900 on Amazon a few days ago because no one noticed. No one was buying that anymore. Yeah. So Amazon's algorithm lowered the price, and I think the 7900X almost got to $420.
Yeah, we'll see then. It's at that point, it's well, I guess I'll get the X. But that also maybe it's a 7900 for around 375, 380 and cooler. Okay, yeah, it's back into no-brainer territory. I mean, you got to get a cooler, but you can get a cheap cooler.
Well, and something I've also reported for a few months now is that every retailer, every mom and pop shop that sells CPUs I talk to, they're we've got a $20, $40, sometimes $60 or more markup on all of our Zen 4 products, even the cheapest ones. If AMD wanted to drop the price, we would still have higher margins selling these than Raptor Lake, which is any Raptor Lake SKU you see at the per 1000 tray price that Intel announced, they're selling them at cost and hoping you buy a motherboard with it. That is what's going. And so
That's depressing.
Right? I mean, it's depressing. So it's depressing for the retailers and that they feel forced to do that. And it's depressing for Intel because it's just, I don't know if people get this. AMD is fine with these margins. And in fact, retailers I talk to want to keep pushing AMD CPUs because they're making $10, $20 on each one sold. Whereas the Raptor Lake ones, they're not. They're making maybe $5. I don't know where Intel goes here. Dino999 writes in and says, hello, Tom and Wendell. With the 13900KS being Intel's recent CPU launch that is truthfully very disappointing, it looks like they finally ran out of levers to pull. Previously, they had the node shrink advantage every generation they could always rely on if they couldn't get a big IPC increase. And then they started increasing the TDP, and that gave them some extra juice to a point. But the recent KS, I'd argue, isn't even better than the regular K, like at all in many benchmarks. What can Intel do going forward? Server, mobile, and soon desktop just seems one-sided. Are there any other levers they can pull, or can they just keep increasing TDP? Well, I'll answer that now. I think we've seen the fact that the KS uses the same energy as the K. They're out of the TDP lever now, even. He says, it seems the next few years will be AMD dominating. I really don't want one company dominating too hard for any period of time. Healthy competition is always good for the consumers.
You can get the KS. I think, again, sample size of 1, but I think the KS is better than the K, but it is different. You can't give it more power, but it will run faster with less power.
Yeah.
And so it's weird because nobody wants to tune it that way. So you can get better gaming performance, but in terms of like, oh, your all-core performance? No, you're not going to get. It's your all-core performance. It's just 24 cores versus 16 cores at the high end. Well, 16E plus 8P. Mm-hmm. So if you want to count an E-core as a core or not, whatever. I'm not going to have that argument with you. But 24 things that compute versus 16.
I count them as cores.
Yeah. Well, I mean, they're Skylake cores.
Exactly.
I called them cores on the 8350. So I figure it's only fair if it's cores in the, in Alder Lake or in Big Dot Little. They don't like it when you call it Big Dot. But yeah, they're out of, and in server, the server is a bigger problem than a lot of people talk about, because in a data center, these data center designers designed, for 22 kilowatts per rack or less. And you just can't do it. And it's like, oh, we got these Xeon Max CPUs that are the Q series that are designed for water cooling and blah, blah, blah. It's like, okay, that's for like 2 customers. Nobody's going to buy that. Nobody's going to buy that in bulk. And certainly for the Sapphire Rapids CPUs that I have, they're fast, and single core speed is at parity or beats, what AMD has in Genoa. Mm-hmm. But that single core, notice I'm really careful here, single core speed, meaning that the other 43 cores aren't doing anything. And
because people talk about this, right?
Yeah.
And I think this is something that surprised people that Zen 4 kept up with Raptor Lake in gaming. Intel typically has a single thread lead, and AMD has multi-threading lead, but in the middle, AMD still has an advantage because their 8-core performance tends to boost higher at the same time.
Yes, it is not a great situation on server because so many workloads aren't really single thread. And so you do your single core test, like the PHP benchmark in Phoronix, that's basically single core. And you look at it and it's holy moly, we've broken 1 million points for PHP. This is going to be the most amazing web server on planet Earth. But then you look at the power usage and it's like, oh, that 1 core is using the power of 4 cores. Mm-hmm. And there's physically not a possibility that you will ever deliver that much power through the socket to all of these cores. It's not even a thermal problem. It's a power problem. It's a power problem before it becomes a thermal problem. And a power problem and then a thermal problem about 30 seconds later. Even with water cooling and
that's what NVIDIA's run into with Lovelace too. They're like, they can actually cool it, but you will trip the breaker in your house if we push it too hard, or the card will melt itself.
Yeah, exactly. And so for some things, it's really fast. And then when you're running, 20 of your 44 cores, and then all of a sudden we're at core parity with Genoa. But in terms of performance per watt, Genoa is leading in. Even in the other side of the bathtub curve, performance per watt parts, the F CPUs, the F CPUs are still more power efficient than Sapphire Rapids in those middle of the road Sapphire Rapids performance scenarios, unless you're using some of the Intel specific silicon, and then the performance per watt goes through the roof. Like when we're talking about like 1DNN or OpenVINO or things that are components of Intel's One API. If you look at the performance per watt, and there's some aspect of the job that can leverage those parts of the processor, then the average performance per watt is through the roof for Intel, like significantly better than Genoa. But the problem is that there's a lot of workloads out there that don't use any of that. And for the generic things, the performance per watt is quite a bit worse than AMD for Intel.
Yeah, so yeah, let's get into the whole Sapphire Rapids versus Genoa discussion here. Jessie here may know how to fetch very well, but she really hasn't learned one of the main things any viewer of Moore's Law is Dead should know by now, and that's that you don't need to overpay for Microsoft keys. This piece of content is brought to you by cdkeyoffer.com. There's just no reason to pay exorbitant monopolistic prices for Microsoft Office or Microsoft operating systems anymore. Not when you have someone like cdkeyoffer.com, who's been a fantastic sponsor of Moore's Law is Dead for many years now. If you're looking for anything from Steam games, Origin games, Uplay games, or PlayStation keys, or reasonably priced Microsoft software, go to cdkeyoffer.com today, click the links in the description, and use the offer codes BrokenSilicon for 25% off Microsoft keys and DieShrink for 3% off everything else on the website. Don't be like Jessie here, who's chewing on my chair right now. Be smart, don't overpay for online software, and go to cdkeyoffer.com today. One thing that I found really odd about the Sapphire Rapids launch, finally it has launched, like it actually is getting reviewed by websites. I think they pretended it launched 3 times before now.
You can actually buy it. I know someone that's taking delivery of a number of racks of servers in March, theoretically.
So it finally has launched by now. And I swear last week I saw nothing but hot takes. It was either this thing is a joke or this thing is impressive compared to Milan, which I found perplexing. How many people?
Well, it was supposed to come out a year ago. I guess you can see that.
But it didn't. There are people like, wow, this would have been impressive if it came out against Milan. And it's like, I mean, imagine if Ampere came out now and people were like, this would have been impressive against RDNA 2. It's like, okay, but it didn't though, and when something comes out matters.
I know some folks that ordered some systems, not a lot, just have, a couple $1 million worth of servers is not even a blip on the radar. But I know somebody that ordered a bunch of systems and they actually made the call to see, and it was for 3rd gen Xeon Scalable. And they actually made the call to see if they could cancel the order. And it wasn't, it's not anybody that is even considering AMD. They're impressed with AMD's performance. So they're not considering. AMD was never a consideration for buying anything. It's that the performance of Sapphire Rapids is so much better than 3rd generation Xeon Scalable. It's why did you even sell us this? Because they could not physically buy them at launch day. They only were just able to, sign the dotted line.
Ice Lake Xeon had a very, very long ramp.
Yeah. So, and it's like, if you knew that we could buy this and take delivery in, March or April, why did you sell us these? Because we haven't even taken, we signed a contract, yes, but we haven't taken delivery of these. And this is garbage level performance for the 3rd generation Xeon Scalable for what we can get 4th generation Xeon Scalable, which is going to be like twice as fast for this particular job, this particular workload thing that they're doing, twice as fast per dollar. And that has made them very salty. And because of that, they're now considering, maybe we should look at AMD.
Well, that's something that's really, really important that I haven't had. There's a few like server people, if you will, that I've talked to throughout the year. Some of them have come on the podcast anonymously. And one thing that they consistently say is you have to remember that these companies aren't buying into one generation.
Yeah.
They're buying into the next 3. And so that's why it took AMD forever to start taking, relative to what I think some people expected. You look at Naples and you're like, it's half the price and just as good. And Zen 2 is double as good for, It's like, well, they want to see Zen 1, Zen 2, and Zen 3 happen without any hitches so that if they buy Zen 3, they know Zen 4 and Zen 5 will also go well. That's why it took several generations for AMD to start taking server market share. But that's also why I think what we're going to see is now that AMD's starting to take it, it's almost a foregone conclusion they're going to take a way more this year as well, because the decision to buy Zen 4 was made when Zen 3 raffle stomped Intel. And if Intel delivering one generation of Sapphire Rapids, kind of like Alder Lake on desktop, that seems to catch up briefly almost, but then they lose the lead again for that. That's what people are thinking about when they buy servers. They're always thinking, am I buying a winner for the next 5 years, or am I buying a winner that just happened like a flash in the pan and that I'm going to regret getting these? And I think a lot of people like who would say, you know what, Ice Lake, we just got burned, and Emerald Rapids looks like a complete joke. So why am I getting Sapphire Rapids? Why'd you do this to us, right?
Yeah, exactly. And, I don't have anything to do with those conversations. Sometimes I'm on the conference call where these things are being discussed, but most of the time it's just, okay, my stuff doesn't really matter as long as the performance is reasonably good. But you're right. These systems are systems that have a service lifetime of at least 3, usually on the order of like 5 years. There is an ungodly number of Cascade Lake and Skylake Xeons that are still out there. And Intel really, really did successfully sort of buy their way out of the socket apocalypse a couple of generations ago, because they were able to just basically turn to all those customers that had all those 3647 sockets and say, look, we give you a 28 core CPU for that socket that is drop-in ready. You bought the 10, 12, 14 core CPUs for that socket. You just have your data center monkeys go through and replace, we'll send you pallets and pallets and pallets of 28 core CPUs. It's drop in. You don't have to change anything else. It's just the labor, which is still, there's CTOs looking at this and they're like, well, labor cost versus totally replace the hardware. They're still leaning toward totally replacing the hardware just because of the headache.
You don't need to mess with your software as much. You don't need to worry if there's different bugs versus if you switch to AMD. And well, Intel has their own foundries. They're able to pump out chips while AMD was supply constrained during the pandemic. So that's really what saved Intel's market share at all then.
Can't do it again.
Nope, you can't. You did it once, and they were kind of hoping if they bought up all these 28 cores that were drop-in compatible, that 3 years later you guys would have caught back up to AMD, and Sapphire Rapids has not. No. Right? But I would say Sapphire Rapids versus Genoa is better than Ice Lake versus Milan. Because let me just summarize here before we get into like how important these accelerators actually are. Like, we have 60 Golden Cove cores versus 96 Zen 4 cores, 8-channel DDR5 versus 12-channel DDR5. Correct me if I'm wrong, 1.5 terabytes of max memory capacity versus 6 is what I read.
You can do 6 terabytes. They pulled out, they did some knobs and levers at the last minute on Sapphire Rapids, and you can do 2 terabytes per socket on the Supermicro platform that I have. But you can do 6 terabytes per socket with the Optane persistent memory, but that's second gen. That's a second gen product. And so it's kind of like,
yeah, so, and then 80 versus 128, or I think it might be 112 PCIe Gen 5 lanes or something versus 128.
Yeah.
So AMD, and AMD does have data stream accelerators as well. So when you look across this, it's like 50% more cores, 50% more channels, even more memory and more PCIe lanes. It kind of seems like AMD just has them beat across the board. But a lot of the hot takes also talked about how impressive their accelerators are, which they have a data stream accelerators like AMD, dynamic load balancers, and memory analytics accelerator, quickest 6 technology. All this comes together in some AI workloads. They win by like a lot against AMD.
Yep.
But how important is that? Because I think it's like, I think sometimes people go online and they like they break something into 4 buckets. They'll be like, there's gaming, multi-threading, AI, and whatever. And they'll say, well, one wins gaming, one wins multi-threading, one wins AI, one wins this. And they're like, they win half of the tasks. And my question for you is, right, but what percentage of the tasks it's good at are people actually buying these chips for?
In the enterprise, it's usually done much more holistically. Usually the customers aren't idiots. Sometimes they are. Sometimes they're just like, we know that the application works really well on Intel, blah, blah, blah. We'll just buy the next Intel, blah, 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 and it'll be fine. But we're getting to a point where when we're talking about a network card, a mainstream network card that's 400 gigabit, or 800 gigabit, two 400 gigabit ports or whatever. I mean, I'm some rando and I have 100 gigabit infrastructure in my office. what sort of crazy world is this? When you're talking about those kinds of bandwidths and those kinds of latencies, a lot of stuff really matters a whole lot. And there's a lot of cool stuff on the software side in one API and in one DNN to make developers' lives less awful. So my background is computer science, and I've done a lot of I've done a lot of programming in my life, a lot of suffering. It's awesome, he said, with Stockholm syndrome. And anything that I can do to leverage a platform or do something clever and squeeze a little bit more performance out of it is great. I love that. And I love the ambition of one API where I can write this thing and it'll run on Arca GPUs and it'll run on blah, blah, blah. And it's got some seriously cool wins in with Tencent and a lot of projects in China and mobile acceleration in China and a lot of really cool stuff that is not necessarily directly applicable to the American market and potential American customers that would be interested in that or not. You can't just go to them and say, look at this amazing thing we did for Tencent. And they're like, China. But the software aspects and the stuff that's baked into Sapphire Rapids really do pave the way for that kind of stuff in the future. And so it was really kind of mind-blowing to me that they really hobbled the accelerators as they have, because historically, like, Pat Gelsinger needs to go into Intel and go find the team that did the presentation for Skylake to Netflix. Hopefully those guys haven't been fired. So Intel Netflix was doing the whole AMD versus Intel thing years ago, and Netflix blogged about it. But the short version is, they couldn't get web SSL encryption to run fast enough on those old Xeons in order to saturate the 100 gig links or whatever they had in their Netflix boxes. And they were like, that's the bottleneck in our application. We're not buying the most expensive CPUs. It doesn't even necessarily, I think, make sense on a modern system to go 2 sockets, because it's just cheaper to buy more systems and have more sockets, because that thing scales across physical nodes really well. And Intel was like, no, cool, it's cool. We got this. And so they had something like a quick assist accelerator PCIe card, and it's like, look how much faster this will be. But there wasn't enough PCIe connectivity. There wasn't enough PCIe bandwidth in the socket to fully accelerate all of that web SSL traffic and send it out over the wire at 100 gigabit. Like, they fundamentally misunderstood the problem that they were trying to solve. And it was like, accelerators. And it's like, okay, the Netflix engineers were too dumb, from Intel's perspective, were too dumb to figure that out. So they sent their sales team, and then when the sales team got there with the accelerators and everything else, they were like, oh yeah, no, we can't, it doesn't work like that. And it's like, yes, exactly. And so here we are again with PCIe 5 and accelerators and weird licensing and blah, blah, blah. And everybody that has already been burned by that, everybody that has already been burned by those PCIe quick assist accelerators, everybody running more than $250,000 Microsoft SQL licenses has already experimented with all the quick assist stuff, and they have already been burned by it. And that is going to really, really hobble the one API adoption unless Intel comes hat in hand. No, we want 60% of this to be for the betterment of humanity and less suffering for developers, and 40% to lock in our market share. If it's 50-50 or 60-40 the other way or more, no one is going to adopt it.
So for Netflix, assuming they could leverage the software well, Intel did go hat in hand, and let's say they had to rebuild everything they had right now, would you recommend they build a bunch of Sapphire Rapids servers or a bunch of Genoa?
I think, well,
which one would outperform for the price, even just in terms of like electricity?
Right now, even with the accelerators, even on Sapphire Rapids, nothing would make sense to rip out the infrastructure you have.
But if they were building it new, if they were building new,
I don't think that Sapphire Rapids right now closes the gap enough for that.
For Netflix. Okay.
Yes. And here's the thing, maybe the potential leakers in your audience that would leak even more stuff to you. AMD's acquisition of Xilinx, is that how you say that?
That's how I say it. So sure.
So you can do those same kinds of acceleration actually on the network card. So like DPUs, data processing units.
Yeah.
But again, it's a problem with software. So the future, like where this is going, is basically if you believe in a top-down benevolent dictator approach what Intel is doing, will that win? Or will AMD's approach of, we're going to work with our biggest customers to figure out what they're doing, and we're going to try to make it easier for them to do what it is that they want to do, but it's ultimately going to be up to them to fill in the gaps in the software and be able to do that. And I think Netflix is going to choose to be more self-reliant. And I think they would choose the Genoa system over the Sapphire Rapids system, even though if all of the sun and the moon and the stars align, one API might be a less awful developer experience for Netflix, and Intel may have an answer there for their customers to really dot the I's and cross the T's. I think Netflix would look at the raw, just crazy horsepower of Genoa, more memory bandwidth, and the possibility for future flexibility and to deal with unknowns.
Like adding other accelerators on top of it instead of relying on only Intel's.
They could build their own, they could do their own thing. And because you have somebody like Netflix that has historically been so self-reliant and also very smart, they're going to choose Genoa every time. If you have somebody like Ford, poor old Ford, they're it's just, well, we'll invest in EVs, and then the whole fake. It was Ford that invested in the fake EV company, right? They didn't have anything. The semi was going downhill.
Oh,
was that Ford? Am I thinking of the wrong company? I don't know.
No, I know. Because I used to work at GM. I don't believe it was GM. I think it may have been Ford. Yeah, it was. There was a big auto manufacturer that did that. Yeah,
and so you have somebody like that, and they're like, "Gosh, Intel's gonna show us the way out of this mess with their one API." There may be an enterprise customer like that will do that. As a developer, I really like the promise of one API, and I really like the top-down recognition, and I really like that they have the smarts to put something together like with one API that could show us the way. It's like, give us the computer science and give us the awesomeness in order to be able to do this. And they did that a little bit with Optane. Like, Optane was so fast and so low latency, they had to invent a whole new storage thing to be able to deal with that. And that was called SPDK. And there's a lot of really amazing engineers and a whole bunch of people that got fired from Intel because Intel's like, getting rid of Optane, whatever. Really treated unfairly engineers because somebody didn't see the big picture, in my opinion, that figured out how to make things like PostgreSQL go insanely fast. Open source database system go insanely fast. This is great. That's on that 60-40, 60% benefit for humanity, 40%. Maybe Intel locks in some market share here, but I think that's good. And, they got to have some incentive to make money and do stuff. And they did some really amazing stuff with SPDK and PostgreSQL and blah, blah, blah. But it turns out you don't need a SPDK to make the NVMe and the I/O go fast. The fundamental I/O problems that, Intel and AMD were facing with fast I/O devices, fast storage devices could be used as persistent memory. It could just be used for storage. You can also solve with something called IOU ring. So it's actually new computer science, kind of, more or less. Yeah, it's unequivocally it is new computer science to do with reusing buffers and how things are transferred. And so that approach, pure open source in the Linux kernel, is supplanting what SPDK would have been used for in those scenarios without being encumbered by Intel intellectual property. And so there are things like that could be potentially very bad for one API adoption. Mm-hmm. So between that and charging money for one API, I think that was bad. That's bad news for the future of Intel-owned accelerators.
Well, so do you think, because I want to get into that, but do you think that Intel put money into the wrong accelerators on Sapphire Rapids, or do you think this is all logical? This is the only thing they could do? I'm kind of coming at this from the perspective of, like, I'm looking at a die diagram of Sapphire Rapids on the side here, and the accelerators take up like the equivalent of like a few cores, maybe, on the overall quadruple tile thing that is Sapphire Rapids. So it's not like they use that much die space for it. Is this something they just kind of had to do because they can't scale up in cores as high as AMD? Or is this something that this was a waste to do? Did they bet on the wrong accelerators? Or do you think, we're just being as critical as possible? It might have been it's fine. It actually isn't that bad. It's just not magical. Or you see what I'm kind of asking here?
Yeah, as in terms of your question is good, but I'd probably ask it a different way. For the accelerators that don't really take up a lot of silicon real estate, does it make sense for Intel to even bother licensing them? And I think the answer is no, because you look at the die diagram and you look at how much silicon real estate that it takes up, and it's like, what are you,
very little.
What are you doing? Why are you charging me so much money for this? This is crazy. But the reality is that there's actually a lot more that went into, I think, I this is opinion, this is not based on specific knowledge, but I think that because of the software architecture, I think the software people are leading the hardware design in a lot of ways. I think there's the overall processor architecture design was based on a lot of assumptions that they made with how one API would be built so that things will drop into one API. Because for things like the OpenVINO acceleration and AMX, the AMX acceleration, it's not really, I mean, it's just advanced matrix extensions. And so like that's probably not even in the part of this, I don't know, but it's probably not even in the part of the silicon that you're looking at. It's probably in with the other vector extension stuff in the processor. And that stuff had to be built with the software in mind for how Intel was going to take advantage of it from the one API side. And so it probably is a lot more silicon real estate.
I see what, than
it looks like.
It's kind of like talking about like AVX 512 on Alder Lake, where it's like, well, whether they liked it or not, that's taking up some silicon, and they just had to disable it to use the little cores. Or I don't know if they really had to; they've chosen to.
Well, it's funny because there's actually in this same conversation, we don't have to talk about it right now, but we need to remember to talk about the AVX 512 Alder Lake thing, the Sapphire Rapids stepping thing, and this that we're talking about now with in terms of like silicon real estate versus accelerators, because I think they're all connected and they show holes in process that I don't know that Intel has solved, and that may affect Granite Rapids and future processors.
Well, so right. Well, then here's how I kind of want to answer or ask this question as well, just kind of like nail this down. Like, all right, the accelerators can be useful. It sounds like you're kind of saying because there's other ways of doing it that they can control better on their own. A lot of companies will just not use these accelerators. Let's say if it was this simple, AMD could have the same accelerators that work the same way, that work just as well. Would you remove 4 cores from Genoa to give it the same accelerators Sapphire Rapids has? Would you say, easily, make it a 92 core instead of a 96 core? Now it has all of the accelerator capabilities of Sapphire Rapids. Would you remove 8, 16? How many would you? I know it's a very qualitative answer to what should be a quantitative one, but
4 cores probably would be yes if you can leverage all of the accelerators in the same way, and that would probably help drive the adoption of those accelerators. But
would you remove 8? Would you make it an 88 core Genoa to get the same accelerator capabilities as Sapphire Rapids?
8 is pushing it, and
12 is right out.
Yeah, no, definitely not 12. 8 cores is pushing it, and the only reason for that is because the 1DNN like OpenVINO results on Sapphire Rapids truly breathtaking. Like the latency there is so small, and that could be potentially like those features could potentially be critically important for some future AI thing that runs on combination CPU and GPU. Like probably I think we're going to see an AI software system that is probably indistinguishable from something that is sentient within the next 5 years. And it will probably be running on something that is a CPU, a giant package that has tiles for both CPU and GPU compute with insanely high-speed interconnects and HBM memory. In the same way that you can run Windows 95 on a 386, you're going to be able to run AI on something.
Yeah.
And those accelerators are really good. But it's also true that they're kind of narrow in scope. And so...
And that's what I was trying to answer, right? It's like, well, yes, in some tasks, this is a huge boon. But also, it's like you wouldn't give up, it sounds like, even 10% of the cores to have this acceleration. That probably means it's only being used by not 10% of customers then, right?
Yeah,
or
when you
it's not like half of the customers can benefit fully from this.
It's a game of balancing speeds and feeds. So you've got so much memory bandwidth, you've got so much IO bandwidth, and you've got these breathtaking accelerators. If you can't feed the accelerators from all of the other stuff you got going on, then they're not going to get utilized. And the accelerators in Sapphire Rapids are so fast. It's easy for me to imagine that the workload doesn't depend on just the accelerators. It depends on everything else. So if you lose a relatively small number of cores, you're not really hurting the overall performance of the chip for everything else. But at a larger number of cores lost, then you lose so much. You gain so much accelerator performance, you lose so much other performance that you cease to be able to keep the accelerators fed.
Mm-hmm. And that's kind of what I suspected too, but I this just isn't my background. So if I felt like if I articulated that in the last Broken Silicon, it'd be obvious I'm way out of my depth. But something I discovered today also while I was preparing to talk to you, something I've seen said online by a lot of people is, oh, well, this can cut down on per core licensing and the accelerators aren't a core to be licensed. And then I saw, well, Intel's charging to license their accelerators. Yeah. Anyways, Chris Rich writes in and says, the accelerators built into Sapphire Rapids are certainly useful for a number of tasks, but I feel that Intel has made a mistake by deciding to charge extra for them with their on-demand program. I think this will put two doubts into consumers' minds. Number one, what about whether these accelerators will continue to exist in the future, and then also whether better alternatives exist for the money already right now if they're going to charge for them. In fact, I'd expect customers who would particularly benefit from them to already have alternatives they're using now in the form of PCIe cards and the like. Are Intel shooting themselves in the foot by charging for this? You've kind of gotten into that already.
Yeah, Intel is absolutely shooting itself in the foot here. They have the quick assist accelerator PCIe cards, which were great if you had one of those anemic Xeons from way back in the day. Well, way back in the day is like, pre-Sapphire Rapids, I guess. Yeah. Well, pre-Ice Lake, actually, probably. And so things would run fast and be great because through the PCIe card. Woo! That's really good. But in modern CPUs, it's faster to just leave it on the CPU. It makes no sense to actually move it off of the CPU. So, but now we got PCIe 5 where it's like, well, the bus is actually really kind of fast again. So the network, even at 800 gigabit, the network is so much slower than everything else. You could theoretically move everything onto an accelerator and then off the accelerator onto the PCIe cards. But like it's like there's a whole other. There was a project I worked on once where we were looking at moving stuff on the PCIe bus peer to peer. So that's a thing you can do, but that still hasn't really largely been realized everywhere. Everything still goes through the CPU, but it's frustrating and it doesn't make any sense. Nvidia, ironically, is one of the few companies that has really dotted the I's and crossed the T's on their implementation to do that, and with these large, 80 gigabyte GPU systems, which if you did that on a PCIe 4 system, you were in a better spot than if you used AMD or the proprietary NVIDIA crossover thing. So if you run all these NVIDIA GPUs on an AMD system and just gave them all the PCIe bandwidth, the CPU is not really doing that. It's really running over Infinity Fabric. You're not losing CPU cycles to deal with that. Just the virtue of Infinity Fabric running all those PCIe slots. It ran circles around anything that you could use from Intel on the Xeon side, and that continues to maybe still be a problem with Sapphire Rapids. I don't know, but I saw a demo system from Nvidia that seemed to be Genoa based, and it was like, wait a minute, Nvidia, aren't you guys like mortal enemies? I thought Sapphire Rapids was going to be the demo system for the H100s, and it was a Genoa system. And,
interesting, because that did stick out when they did that, oddly.
Yeah, and it's like, well, it turns out that was faster. It was faster to have the GPUs communicate amongst themselves via PCIe than NVIDIA's own proprietary thing, which was invented because it was too slow on the Xeon side. And there wasn't enough lanes. It's like, And so you end up with this, instead of having every GPU with 80 gigabytes of memory, every GPU has 80 gigabytes times the number of GPUs in this cluster. And whether it's local or remote memory, it's so fast, it didn't really matter.
Well, and something I kind of want to move into now as well is I see one of the hot takes that really annoyed me the most when Sapphire Rapids just launched was seeing people say, well, at least it's good compared to Milan. And then not see those people bring up that this Sapphire Rapids isn't even just competing with Genoa. It's competing with Siena, Genoa-X, Bergamo. Those are all coming out in like 4 months or something. I think Siena is more like later in the year, but like Siena's a 64 core Zen 4C. I think it has the same IPC as Zen 4. It's just clocked lower.
Yeah.
And so that's basically half the price for the same multi-threading almost as Sapphire Rapids. And then you have Genoa-X, which has, I don't know what, gigabytes of cache now on it, and Bergamo, which now goes up to 256 threads. So if you want multi-threading, Bergamo. If you want 64 cores or less for cheap, Siena. If you want the standard, Genoa. And if you want the cache, Genoa-X. Is this just about to get 10 times worse for Sapphire Rapids? Because really, customers can use whatever niche they want from AMD.
Yeah, you'd be surprised how many people are still buying, less than a 32 core. It's like, oh, this is a pleb tier server. And it's like, we're going to buy a box and have a cluster of, 24 core machines running a bunch of VMs that do whatever we need it to. And that's all we do. So Mark Papermaster in his conferences at AMD has said AMD is working on opening a whole bunch of swim lanes in parallel. And so AMD doesn't subscribe to this accelerator powered future, or doesn't subscribe to this. I should qualify and say that my impression is that they don't subscribe to this top down, AMD led accelerator future. And that AMD is opening swim lanes, his words, for more products, and that's sort of it's sort of a new thing for them. And so Genoa-X is and Milan-X are sort of running parallel, and there's no reason that everybody needs DDR5 12 channels right now. Milan-X solves a lot of problems really, really well right now, and will solve a lot of problems next year and the year before. It's almost like AMD's got their socket 3647 moment where we start out with those 12 cores and then you swoop in and it's like, oh, would you like a 28 core that fits that socket? Like, and AMD's like, we got this room over here that's just filled with these CPUs. Why don't you take one of those?
Well, and I think a lot of people choosing Genoa this year are aware of that as well, because Genoa is and Zen 4 on AM5 really are just setting this table. Like Turin, I believe, is 192 cores next year. And then whatever the follow-up to Bergamo is called is 256 cores.
Yeah.
And so you can start, and they're going to have a follow-up to Siena as well. You can get like a budget 32-core Siena system that probably costs less than Milan and outperforms it. And if you want to upgrade to like a 128-core Bergamo next based on Zen 5 next year, go for it, man. You want to go from 48-core Genoa, to 192-core Turin X, go for it. I really think when people compare Sapphire Rapids to Genoa and they go, oh, but it wins this task and that task by a little bit here and there, it's like, right, but now compare it to the multi-threading of Bergamo. Now compare it to Genoa-X in terms of any single, like less than all multi-threading, or all multi-threading tasks that can use a lot of cache. It seems bloody.
It's going to be... It's going to be interesting. It seems like it's going to be good for AMD, and I think that I think they meant a lot more than they let on when they're talking about opening up multiple swim lanes and the products that they have and everything like that. Because look at how many servers would be completely satisfied by the reject silicon. By years old reject silicon that's been sitting in a warehouse forever. It's like, oh, look, here's your 24 core, 4 sticks of DDR4. How happy is it going to make partners that you're still selling DDR4 memory and servers and blah, blah, blah? How insane is it that, a DDR5 platform, Sapphire Rapids, compared with Milan's still doing pretty good there. And it's DDR4 and it's less memory bandwidth and not PCIe 5 and blah blah blah, and it's like, oh, it's PCIe 5 to PCIe 5. I mean, that is there are aspects. I get that Sapphire Rapids was supposed to be out first and that Intel was supposed to be the first platform with DDR5, but at the same time, it's like, you kind of want to compare DDR5 to DDR5 and PCIe 5 to PCIe 5. And I really hope, like, if you want to be really harsh about it, AMD with 12 memory channels of DDR5 is not doing as well as Sapphire Rapids is with 8 channels of DDR5 in some scenarios.
Mm-hmm.
And what's that about? Is that what's going on with DDR5 in general? We see that over in desktop parts as well. The AM5 DDR5, there's some sort of weird, like if you just do the math on the bandwidth that you should get from DDR5 and the clock speed, the latency and everything else, it's like, what is going on?
Yeah, I mean, obviously I can't answer that.
I don't know. Like, I've got some pretty good connections, and they're just kind of like, well, we know, we're not going to give you any hints. And it's like, okay, that's cagey.
Well, I think they got it out the door. It does what it does against what it's competing with well. I guess you would just hope that with Zen 5, it's like, oh, well, guys, this is the full new architecture from the ground up that's going to utilize this really well or something. That's kind of how I see it. In fact, this might give you some pause. This is like half a year ago, and there were other rumors online about this as well, that there was an AM4 version of Zen 4 designed. And so I don't know what that exactly was, but if I were to guess, Zen 4 is the exact same chiplet size as Zen 2. If I were to guess, Zen 4 can use Zen 3 IO dies if they really wanted to. Just AMD axed that plan to release it to AM4. That's what I suspect. And so I would look at Zen 5, or who knows, I'd like to see Phoenix test it even, because it's like a 4 nanometer updated version. Like, I suspect these next generations of Zen products are the ones that really were from the ground up built for DDR5. That's my suspicion. And that in many ways, Zen 4 is meant to be a bridge, because they were just like accounting for so many things. Like, is there going to be a huge recession? Is there not going to be? Is AM5 going to get delayed?
Yeah.
Because if you keep compatibility with the previous Gen IO die, that opens up a whole host of possibilities if something goes wrong. You could release it on and then you could release Zen 3 in the low end on AM5, because that would suggest maybe Zen 3 is compatible with the Zen 4 IO die. Probably not, but it makes me go, But I don't know about you guys, but over the holiday season, I tend to eat extra calories, and Jessie here is no different. She's probably about to go eat that bone right now. But Jessie's a growing girl. She eats as many calories as she can get, and she's also a dog. She doesn't really think about if any of those calories are healthy, unlike probably most of you humans watching who are about to go back to work after the holiday season and want something easy to make that hopefully will help you get off some of that holiday weight. If that's you, consider getting Vite Ramen. Vite Ramen is a sponsor of this piece of content, and Vite Ramen is an American company that crafted a protein and nutrient-rich meal that takes minutes to make without sacrificing taste. You can use their classic packages that make it easy to add protein and ingredients of your choice, or the new Ramen Go packages that let you microwave something quickly if you really only do have a 15-minute lunch break. And Vite Ramen has been an excellent sponsor. Moore's Law is Dead for over a year. They've been good to us. So if you're looking for something like this, be good to them. Click on the link in the description and use the special New Year's Eve holiday code Moore's Law to get 10% off any order and a free package of ramen additionally while supplies last. Go to the link in the description, use the offer code Moore's Law, and buy Vite Ramen today. Quick Jumper writes in and says, analysts and investors predict that by the end of 2023, AMD could reach 30% server market share. Could AMD really reach like 40 or even 50% before Intel gets competitive again? Well, I'm not sure it's competitive. I guess let's just say that's Diamond Rapids, because I don't know that Granite will win, but I think it could come close if it comes out in time. Diamond Rapids, end of 2025, early 2026. Do you think AMD could get to 40% server market share by 2026?
It's possible. I mean, if Intel needs the software wins in order to maintain the momentum, I think there's a lot of large customers that have lost confidence, and because it has been so many generations of incremental gains. And it really is going to be make or break. Like, the next thing after Sapphire Rapids has to be as much of a gain from Sapphire Rapids to the next thing as we saw from Ice Lake to Sapphire Rapids. I mean, it is literally insulting if you just, sign the contract for your Ice Lake system that you haven't even taken delivery of yet, and you see how much faster Sapphire Rapids is, but also availability. Like, I don't know if Intel has lit a fire under the butts of companies like Supermicro, but you can take delivery of Sapphire Rapids systems really, really quickly.
Mm-hmm.
And that was not the case with Ice Lake. And because
10 nanometer works now.
Well, Ice Lake is so much slower than Sapphire Rapids. It's shocking.
Mm-hmm.
The upgrade from Naples to Rome was pretty big on AMD's side, but it is breathtaking from the 8380 to the Sapphire Rapids, the 8480, and then the Q series is going to be even beyond that. Presumably the big enterprise customers have seen that. And then Intel's got to do it again in the next generation. They have to move that much again in less than 12 months. And that seems like a big bet.
Just to answer that question directly, my understanding is Emerald Rapids comes out hopefully by the end of the year. It was supposed to be what was supposed to happen is Sapphire Rapids was supposed to come out early last year, and then Emerald Rapids was supposed to come out mid this year. But now, because Sapphire Rapids has been pushed back so much, it might come out the same year as Emerald Rapids. Now, Emerald only adds 4 more cores. It's 64 cores, tweaked cores, not kind of like Alder Lake to Raptor Lake cores. And I assume somewhat better accelerators and clock speeds. But that's it. I think you're looking at a 20% boost in performance with Emerald over Sapphire this year. And the hope is to have Granite out by Q2 2024, so next year. So I guess what I'm saying is Emerald will not be a doubling over Sapphire. It's going to be quite a stopgap. And I keep wondering if they'll just cancel it because it's almost not worth it with how delayed Sapphire is. At the same time, though, a year and a half after Sapphire, Granite is supposed to go up to 128 cores, over double the core counts. Probably over Golden Cove, I would say 20% higher IPC, probably at least, and
that might not be enough.
Well, it's over doubling in performance, but is that enough against 192 core Turin? It's probably better than now. 128 versus than 60 versus 96, but it kind of seems like it's a 20% better situation than now. You think it's not enough? AMD's just going to get to, probably, we don't know for sure, but to 40%.
all that Intel in order for that to work for Intel, I think AMD has to have a misstep. If you look at the average gains from Naples to now, gen on gen on gen on gen on gen, and you assume that happens one more time in the next 18 months, and it's things are going to be interesting.
Yeah, so because my understanding is Zen 5 is supposed to be kind of like a Zen 2 uplift, in terms of they're going, because if you think of Zen 4, it's a bigger deal than Zen 3, but it's kind of a Zen 3 single threading uplift, and then 50% more cores on server, but not on desktop.
Yeah.
With Turin, I think they're trying to double cores and raise IPC by 10 to 20% again, like they did from Zen 1 to Zen 2. Yeah. So if that comes out a year late, though, if that were to come out 2025, I think Granite Rapids will really have a chance to cement itself against Genoa and Bergamo. But yeah, if that comes out at the end of next year, you really think 40% is possible this soon?
I mean, it seems like that's what would have to happen in order to make all the enterprise customers happy, right?
Mm-hmm.
I mean, now you could get that. You could get that with accelerators, maybe. If you have a thing and it's hey, just recompile your thing with this thing that we have, and then all of a sudden it's 40% faster. You could get there. You don't have to get there necessarily by making x86. It's it's just generically x86 instructions are this much faster. You may be able to get there with accelerators, but I don't know. Just think about generic cloud workload. What does Amazon need to make EC2 go fast? What does Amazon need to do? ABC, XYZ. I worry Intel is super hyper fixated on AMD, it seems, and AMD is at least keeping an eye on ARM because, look at Amazon. Amazon with their Graviton stuff, it is legit awesome, and that is the threat. When you look at what Amazon is doing with their compute instances and their database instances and their microservice instances, Graviton ticks all the boxes. Graviton's not the most efficient per watt. It's not the fastest per clock. It's not the best memory bandwidth. It is none of those things. But what it is dirt cheap.
Mm-hmm. Yeah, and that Sapphire Rapids seems to cost about twice as much per CPU compared to Genoa. If things keep it at this rate, like when I leaked how Granite Rapids is supposedly organized, and it's like, it does not look cheap, like, compared to Turin, which is, it's getting more expensive, but it's still, they're sharing chiplets with desktop. They're dividing it up into a bunch of little cores they can bin. Like, I think it's like up to 44 cores per tile with Granite Rapids. And I'm like, so those are some big tiles. Like, what the heck are you? You're solving I was talking to the co-host of the news episodes of Broken Silicon, Dan, the other day, and I'm like, honestly, it's just like Intel continues to use tiles in a way to make the thing bigger, not more economical. Like when you look at Genoa, it's expensive because of how much silicon it uses, but it's cheaper than otherwise. It's a bunch of little chiplets that saves money. Same with RDNA 3. Even if it falls short of its design goals, it's still cheaper to make than Lovelace.
Yeah.
But with Granite Rapids, 44 core tiles, it's almost like they're like, well, I guess we have to use tiles or we can't add more cores. They're not actually thinking about it in a way that will save money.
Yeah, maybe the hilarious thing that happens here is Intel is the first to go to 4 threads per core or something.
They might be. I'm just letting you know they might be, but the decision hasn't been decided yet. But one of those upcoming architectures I've been talking about, they're considering. I'll drop that bombshell here. But obviously, the decision's not made, and AMD has been playing around with it for several generations as well, and just keeps deciding not to. I don't know.
Security Pandora's box is just
Yeah, I think Zen 6 versus Diamond Rapids may be very interesting. Which is Venice, I guess we'll see. QH Freddy writes in and he says, many people seem to complain about the lack of aggression on AMD's side in the consumer markets, particularly the GPU side lately. I think this comes mainly down to a failure by these people to recognize the internal competition of these consumer product lines. It's the far higher revenue per wafer of AMD server products. What are your thoughts on this regard? Do you think AMD should be more aggressive right now with their consumer product lines? Or do you think consumers should just accept that consumer products at the end of the day are of secondary importance? Because that's something I'm thinking about. Like, I'm kind of hearing in server, AMD's expected to take decent market share this year, but in desktop and laptop, they're kind of expected by the analysts I work with sometimes to tread water, And on the one hand, that's disappointing, but on the other hand, you saying, you think they could get to 40% market share in a couple of years, the amount of money that would give them to make new consumer products is staggering. I mean, they would totally have the money to make whatever they want then in 2 years. They just got to get there first. I mean, do you think QH Freddy's onto something there?
I think that the margin for consumer stuff, the consumers are very, very margin sensitive and are very cost sensitive. And so that's going to hurt your margins. And I think that, if you just strictly look at the cost per unit silicon, it makes more sense as for shareholders for AMD to focus on server stuff, and the other stuff will be secondary. But in reality, I don't really think it's that. I don't think it's that cut and dry. I don't think they're wafer constrained, or at least AMD has repeatedly said, we're not wafer constrained. So I get the feeling that they've got, kind of a backup plan. It's like the plan is we will use this much of our capacity for this, and then if we have another thing, we'll do this capacity for this or whatever. I don't think they're wafer constrained. I think it's really just, time and materials and swim lanes and internal resources to be able to do, this, that, and the other. I think they want to keep those I think if they weren't really serious about it, we would see them, wind down those product lines. Mm-hmm. But instead, I think what they're doing is focusing on the things where they can make the most money. And that probably means not an insane fire-breathing flagship GPU, because the consumer GPUs are different than the CDNA GPUs. And the CDNA GPUs are coming a long way very rapidly. You know, AMD, I think, sort of recognized that software was sort of a problem, and they've tried to embrace the open source side of software for CDNA. And I don't think that that's really had the intended result that they had hoped, which is, you know, people that have been forlorn with the CUDA ecosystem. I mean, certainly all the researchers, any researcher you talk to, it's like, oh, how do you feel about the CUDA ecosystem? And they're like, well, it's a lot of suffering, and I really don't like NVIDIA for it, but it works. And but you know, with Frontier and the other supercomputers, NVIDIA is, you know, losing out on those things at the really highest end. Meanwhile, AMD is using that customer experience to build their products. And it sure seems like for, you know, got to talk to Jeff Woolsey from Microsoft about their adoption of Genoa, and the theme from him was very spooky in how similar it was to some of the other folks that I've talked to. That, you know, because Oak Ridge is just right down the road, and some of those folks is like, AMD's they want to listen to us. Is like, how do you work? What do you know, how do you do this? And it's blah, blah, blah. There's got a lot of really smart people that know all the stuff they're talking about, but they don't come in and they don't say, this is how you should do this. It is, tell us how you work. What can we do to make your life easier? And that was basically what the guy from Microsoft was saying. And he's like, look, we made all of our problems with InfiniBand go away, and we made all of our problems with, you know, because they've got a 200 gig, their Azure thing is like 200 gig InfiniBand for their high performance compute. It's nice. And Microsoft's architecture for how they do things is even better than Google Compute, I think, in terms of the back end. Google Compute is made to be as big and generic as possible, whereas Microsoft is like, well, you know what? We might have some customers that want to build their entire cluster in Azure, and we should probably build it to be able to deal with that. And where Google Compute will fall apart if you try to do that, Azure works pretty well for that. And because of that, you know, because AMD is not coming in to tell Microsoft how to build Azure with their products. It's like, how would you do this? And, you know, Frontier is kind of the same way as researchers. How would you do this? I think AMD is learning a lot about how to build the software parts of that in a way that is maybe more sustainable, and maybe you could call it a little bit more blue collar than what Intel is doing with one API and their programming approach. But it could be more successful in the long run because of what they're doing and how all that goes together. So does that mean that I think the CDNA will eventually go back to the consumer? No, but if you're looking at the nuts and bolts of how CDNA is put together and how RDNA is put together and how they service data on a clock and how their rendering engine is and blah, 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 there's a lot of interrelationship stuff that I wish I understood better and had better insight into. Some of it is special sauce and they don't really want to talk about, but it does seem like there's a lot of lessons learned from RDNA incorporated in CDNA and vice versa, but ultimately the silicon is designed with different goals in mind. Meanwhile, NVIDIA doesn't have that affliction and or advantage.
Dermies writes in and says, hello, Wendell and Tom. Can you talk about AMD's GPUs and workstation, particularly and insights and predictions about near future viability and competitiveness? It's really tough out here with no alternative to CUDA. This is something I've heard too, and something I always hear from my contacts is AMD is getting better. They're still not there.
Yeah.
But it sounds like you think, well, that's true every year. They really are seeing the worry when I hear that is, well, are they really building towards something or not? And you seem to think they are.
ROCm 5 has closed the gap significantly, and it has closed the gap on CUDA so rapidly that NVIDIA is going to have to do some really interesting things in the next couple of generations to maintain their insane captured first mover advantage thing with that. CDNA is very good. If CDNA weren't very good, it wouldn't be as prevalent as it is for the top 500 supercomputer list of the world. The problem is that you have to be a computer science PhD in order to use it. That was true on day one. That's much less true now with ROCm. And Zen DNN, AMD is going to have some big Zen DNN announcements in the next couple of weeks, I think. And it'll be interesting to see what the researchers that have Stockholm Syndrome from the CUDA ecosystem think about where AMD's headed with Zen DNN, because you have things, you have the capability of doing AI things on CPU for things that don't work well on GPU. Like we have a lot of AI that runs great on GPU and it scales well on GPU, but branchy code and other certain types of code don't really work well on GPU type compute structures in silicon, from what I understand. And the best of both worlds is an insanely high bandwidth connection between GPU compute units and CPU compute units, and being able to cache things in the interconnect and blah, blah, blah. And that's what they've designed with Infinity Fabric, and that's what's at the heart of supercomputers. The problem is that they don't necessarily have the software ready to go for everybody to be able to use it. And I gather that there's some hesitation in open sourcing literally all of that, because it's like, ooh, that might be a competitive advantage to Nvidia immediately, which would only let them cement their position even more, because we're basically giving away our secret sauce. I don't know that to be true, but I get that, there's little details like that leak out around some of the way that AMD phrases things with CDNA and the stuff that they make available and blah, blah, blah. If you start today and you want to do interesting stuff with ROCm, you totally can. But I think that perhaps one mistake that AMD has made is assuming that the people that are interested in ROCm are all hardcore programmers. You'd be surprised how many researchers are not hardcore programmers. There's a lot of people that hang out in our forum that are like, I've got my PhD in this. This is what I want to do my research on. I don't really want to futz around with a computer. It's like, they don't have the same passion that I do, which is surprising, because they show up and it's like, this thing that you're working on is amazing, and they're like, oh, I know, I love working on it, and it's like, tell me about your machine, and they're like, I don't care, I just want to hit a button and have my research go, and beyond that I do not care. And it's like, I've
talked to a lot of AI researchers that sound like that.
Yeah, it's just like, I just
let me press the button and run the simulation and then find ways to make the testing better. I don't want to be a computer engineer, I want to be a testing methodology engineer, basically.
Yeah. And so I think AMD has learned that lesson, but it might have taken 4 or 5 versions of ROCm to get there. Because the people that are working at Oak Ridge, those are the people that are passionate about everything. They're like, okay, can we reduce this into so that this is one less ROP and this is one less micro op, and let's move this over here so that this thing does that while this. And so AMD's profiling tools for stuff like that are, I think, some of the best in the business. But it's they sort of fly under the radar because they're so low level and they're so brass tacks that those kind of researchers are like, I don't know what this is telling me. And it's like, well, this is telling you that if in your loop where you're looping through this, if you go ahead and preload the next thing, it's going to speed it up by over 5,000%. And they're like, oh, okay. But, they don't care. They're just like, you make it go. It's like, all right.
Well, it's interesting. You said Stockholm Syndrome. Like, how much of CUDA's advantage really just is that they're in the lead, and how much of it is like,
it's the inertia. You copy,
because I hear people say, oh, CUDA works better, but I don't know if they've tried AMD for the past 3 years. It sounds like you're kind of saying AMD's already there. It just needs to get used.
Yeah, it is there in a lot of ways. It does need to get used. ROCm 5.3. I did a test project with ROCm 5.3. I'm trying to figure out a way to turn this into a video. There's not enough hours in the day, and it's very hard to monetize this kind of content in a way where it's like, oh, it was definitely worth spending 400 hours working on that.
Look at the views of my Xeon leak compared to my AMD CES video. I know. And I'm always just like, Tom, are you really going to do another Xeon leak? Because for some reason, people don't seem to care as often. But I know it's a good video. I would
much rather do an interview thing where it's like, I know that this thing exists. Just come on and let's talk about this thing that you're doing, because it exists and it is really cool. And I did a very small project with ROCm 5.3. And it totally was the case that I just did a search and replace for CUDA functions into ROCm functions. And it worked. And it was fine. And it was totally okay. But you see other things on the internet where people are trying to get, stable diffusion running on RDNA. And it's like, well, you can, but it's not, you really need CDNA, and 64-bit is going to be a problem. and it doesn't really, you're gonna, there's a if, and there's an and there's a but, and there's a well, and it really is an advantage for Nvidia that you can run a lot of the CUDA stuff, on a 3090, and the 3090 is basically unlocked. Mm-hmm. But hot take, when AMD or when Nvidia launched the Titan, the one that had the unlocked floating point 64, mm-hmm. but it was $1,500. That was less than half the cost of the professional card that had unlocked floating point 64 that also ran slower. I think the suits inside of AMD or inside of Nvidia weren't actually interested in seeing if people would buy a product like that. I think they were interested in seeing if people could just buy a $1,500 GPU. An enthusiast would be willing to part with $1,500 to buy a GPU. And because they were, the GPUs have gotten more expensive every generation and worse.
But you unlock these developer features because, well, then they can tell themselves it's for that too, or something, or just get that extra little bit of like mind share telling you it's a good product or something.
Yeah, and every successive generation, up to and including the 4090, they've taken more stuff away and made it way crappier, and the price has also gone up. Mm-hmm. So the whole the unlocked floating point 64 Titan card is still a good card. There's a couple university professors that I know for their research and students that are still buying those cards on eBay for their students, because that is the best deal to get for students. And then don't get me into the whole licensing thing. Like Nvidia is like, well, you can't run a GPU, a consumer GPU in a data center because, we need our licensing money for that. It's very unpalatable. And researchers are clued into that and they don't like it. But what are you going to do? Not use CUDA?
Yeah. So it's interesting. I kind of want to like move into like something I stumbled into in my recent video talking about upcoming products like HEDT, or really they're both saying HEDT is dead at this point. Like they call it workstation now, which I kind of agree. It's a 32 core or higher product. Really, HEDT, it feels more like a workstation product. But I think a lot of people are complaining that AMD hasn't launched a truly next gen Threadripper line next to their existing gen for a very long time now. And then when I look at genuinely like Intel's planning to launch a 24 core workstation product now, then a 34 core up to 34, I believe it is, workstation product later this year in that same socket probably. And then they're going to launch a Redwood Plus Cove, I think is how you're supposed to say it. 86 core workstation product. And AMD might, everything we're seeing is, and this is literally one quote I've been told, is AMD will be lucky. You will be lucky if AMD launches a Zen 4 Threadripper this year, maybe the first half of next year. Do you think this is something AMD has to watch out for, that Intel can really just go in and take back the HEDT market again because AMD is ignoring it? And then I also kind of want to springboard this into a conversation about like roadblocks to market share for AMD in different markets as well, because it seems like we agree they're going to get to unheard of server market share for the size of the company. But like, where does it stop for laptop, HEDT, desktop? Like, where are they maybe neglecting it too much? Or are they not? And are they just doing the correct surgical strikes when they need to? This piece of content is brought to you by Silvernight PCs. Silvernight PCs is a disabled, veteran-owned GPU and CPU retailer, PC repair shop, and boutique PC builder that is located in Fayetteville, North Carolina, but they ship globally. So if you're in the area, drop by their location to pick up reasonably priced components to upgrade your PC, and know that all of these components come with up to a 3-year warranty, and even refurbished products have warranties on them, and you can trade in your own parts for refurbishment as well, or contact them online and ask them about anything else you want them to do for you, including building a custom PC designed just for you. They're very easy to talk to. The owner of the company even sat down with me for a broken silicon last year and had a candid conversation about GPU shortages during the GPU shortages. They really are on the side of the consumer, and they really do put a lot of effort into making everything they sell the best it can be for their buyers. And I know this from firsthand experience. I got my RTX 4090 Supreme Liquid, the one that I am using to render this video in my PC here, and before sending it, they upgraded the thermal paste and thermal pads, and
Well, you can watch the process online. It's actually really cool. And the thing, well, I can tell you that it just doesn't get hot no matter how much power I let the dang thing use. And I can let it use a lot of power. So whether you're in the Fayetteville, North Carolina area and you want to pop in to buy a graphics card, or you want to custom order something from them online, click the link in the description and use offer code BROKENSILICON to get 6% off all orders. Using this offer code BROKENSILICON helps me a lot and it helps them. And I am genuinely happy to finally get their sponsorship, as they really are a business that I can stand by as high quality and of genuine reliability. Go to Silver Knight PCs and use offer code BROKENSILICON today.
I'm a little worried about the Threadripper aspect of it, and the launch in 2024, because okay, Threadripper only for pros, I kind of get, and it's like, oh, this is a processor for enthusiasts. Okay. I mean, are we really going to see a 12-channel desktop board for enthusiasts? Probably not. The people that can afford that are already the people that are using their computer to make money. So that's fine. But, I had one of the factories, or I know somebody, blah, 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 and they said that they're already producing the Sapphire Rapids socket desktop boards. Like, they're already in production.
Oh, they should be. They're supposed to come out, I think, within a few months or something. Yeah.
And I gather that the factory is using Sapphire Rapids CPUs, or modified or unlocked or whatever Sapphire Rapids CPUs to do their qualifications. And so that could be depending on the pricing, that could be bad news for AMD. I've got a 5975X system. I like it. It's very fast. It's awesome. Love it. It is scary how much faster 7000 series AMD is, and it is scary how much faster per core Sapphire Rapids is. And I think all of the silicon that Intel is producing that doesn't meet the power requirements of Sapphire Rapids, even though it's 400 watts a socket, I don't think 400 watts a socket is anyone cares on high-end desktop. If you're somebody in Hollywood and you're doing visual effects and you're doing blah blah blah, don't think you care if it's 500 watts a socket. I just don't think it matters.
It's not running 24/7. It just needs to get this Terminator scene done in 2 hours, please.
Yeah, and so that could be bad news for new sales of that. That said, the VFX industry is not buying new workstations, every generation, and we know that for third and fifth or 3000 series and 5000 series Threadripper Pro CPUs, AMD was basically selling them as fast as they could make them. I gathered that maybe the 5000 series Threadripper Pro CPUs didn't sell maybe as well as they expected, but they could be doing really well too, because I don't know, the stock is generally available. That's the thing that I sort of keep an eye on. Is like, can you buy one? And you totally can buy one, and you can totally buy Sapphire Rapids motherboards right now. But it's still a little bit of a challenge to buy Genoa motherboards. Like, if you just want to go to CDW or some random website and order a Genoa motherboard, a little bit of a challenge.
Well, so, and that's what I wonder, though, is AMD just doing the math and they're like, honestly, these HEDT people, they upgrade every few years and we have the market. So let's just hit it when we're going to hit it really hard every 3 years. But if they don't, they're kind of due to do it, though, this year. And if they don't, I don't know. It's 24 core Sapphire Rapids. It's going to come down to the price, because it's not going to beat Milan in multi-threading, of course. But then I also wonder, well, if it's going to come down to the price, I'm pretty sure the 34 core Fishhawk Falls die is almost it's 700 millimeters squared. That can't be cheap. So and then I go, well, Intel's margins are bad. So it's good. I think it's going to be really interesting, because I think the Redwood Cove Plus version, that one's a threat to AMD big time. They got 86 cores. They're breaking it up into tiles, 6 memory channels. That could be an issue for Threadripper if they don't have Zen 4 out by then. But at the same time, until then, if Intel launches a 24 core that costs $3,000, is that really going to stop people from getting Milan X Threadrippers? I don't know about that, right?
Yeah, probably not. And there's the other aspect of that is there's a lot of people on our forum that got weirdo PCIe cards off of AliExpress that basically give you more USB ports, and there's like 2 or 3 USB controllers on a PCIe card and something else I'm trying to remember. And that would turn your Milan or your Milan X motherboard into something vaguely workstation-ish. Like they just got tired of waiting for the 5000 series Threadrippers.
Oh, so they got the next gen USB support and all of that.
Yeah.
You're saying.
So they're just like, I'm going to take a server board and I'm just going to, because the price difference, there's not really a huge price difference. 32 core Threadripper Pro versus 32 core, F series CPU is like, oh, it's $1,000 more. That sounds like a lot for the CPU, but when you consider the entire cost of the system is about 10 grand, it's like a 10 grand versus 11 grand. I don't care. And they just built their system based around Milan instead of waiting for Threadripper. And there are people right now that are on the forum that are like, I can't buy a motherboard. I can't buy a motherboard. I can't buy a motherboard. And they're just rocking back and forth in their chair because they're like, my supplier can get me a CPU. I can get a Genoa CPU. I got the CPU that I want and it's $4,000 and I can't get a board. And, they're just gearing up to do exactly the same thing where they just don't even wait. They build a server and stick it under their desk and they're like, that's my workstation.
Yeah, I think what I'm hoping AMD is going to do this year is they understand they have an opportunity here to take a large chunk of the server market right before Intel starts being truly competitive again. And so they're just going to go for it and say sorry to the HEDT people for the most part. But Siena has 4 chiplets on it, 4 core chiplets, and it's meant to use 4 16-core Zen 4C chiplets for 64 cores. It's a lot cheaper platform, but I know they designed it to use standard Zen 4 chiplets as well. So my suspicion is, in the meantime, they'll be like, hey, look, if you want 64 cores, Milan's here, Milan X is here in Threadripper, and it's way cheaper than Intel. And it's, 30-40% worse than a Zen 4 would be for half the price. This is all we're going to have this year for sourcing reasons. But if you want that 24 or 34 core Fishhawk Falls, we've got a Siena-based Threadripper system with 32 Zen 4 X3D cores or something. This one, well, I know you wish we were selling you 96 cores right now, but are you really going to get a 24-core Fishhawk Falls over a 32-core Threadripper system that's cheaper? Probably not. So and I think we just have to, I don't want to say accept, but it's like, I just don't think they want to go with 96 cores on Threadripper until they have Bergamo out and all of these other things, because that's just more important.
There's definitely something like that going on because the price of the 5000 series Threadripper Pro hasn't really moved, even though it's generally available. It's not less. Whereas the 7950X has come down in price substantially since launch.
And I think a similar thing's going on with laptop too, where like they only have so much money for laptop designs. They know Intel just did a fire sale on Alder Lake last year, and OEMs probably don't even want to design new AMD laptops this year. And I think if you look at Dragon Range, that uses Zen 4 desktop chiplets. So whenever OEMs are ready to accept AMD CPUs in laptops again in high volume, AMD's like, not only do we have Phoenix, but we also have Zen 3 Plus, we also have Zen 2 products, and we also can just make laptop chips out of our desktop chiplets for extra volume. So I feel like I'm hoping that's what's going on with laptop as well, when we don't see a bunch of design wins in the beginning of this year, is they're just trying to gear up to take it when they can. But if they can get to 40% market share in server right now, that's what's going to give their company money for years to come to really go for everything without taking risk. Because it's really risky if they were to go for like desktop right now and they don't take as much server market share as they could take.
Yeah, I think it is likely that AMD is going to capture more server, because most people buying server are not buying at the top of the stack, and the availability of both Milan and Genoa in the market means that at whatever price point you're shopping for, you're going to be covered. And for any OEMs, it wouldn't, if AMD is not super interested in the margins right now for mobile, it would make sense to go to somebody that mass produces laptops. Probably not like an Asus, but like one of those companies that like basically OEM it for everybody, for every like name brand, but not name brand, but they make it. go to one of those companies and say, hey, we'll basically sell these things to you for as low a cost as we possibly can, but you're going to have to help the OEMs build out the system and do all the details and blah, 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 because all of our people are busy propping up the server market and all these other swim lanes that we've opened and blah, blah, blah. And I think that we see that a little bit. But there were a couple laptops demoed at CES that had really incredible battery life and really, really incredible performance. I mean, Alder Lake is not as bad at the low end of the power curve as some people make it out to be. Raptor Lake is not as strangely, seems like it's worse. Maybe that was just tuning. But
it seems that 65 watts Raptor Lake is significantly better than Alder Lake. But then higher up, it's more power for more performance. And then maybe at the bottom, it's not that much of a needle move, which I think is a 10 nanometer to 10 nanometer. It's not that surprising.
Yeah, it almost looks like it flips at around the 65 watt mark. Because if you're running like one of those 15 or 25 watt parts, it looks like the 13th gen is using more power for some reason than the 12th gen. And then the crossover point is like, well, 65 watts, you get more performance for the same power. And then it's more power, more performance beyond that. And I don't know what that's about, but there are a couple of I'm watching closely to see how they pull it off for those wins in laptop, because AMD's also got their new chipset that does Thunderbolt, and so there's a lot of little things that make me think that AMD is challenged when it comes to software engineering and software engineering talent, because it's the 10. Can't remember the PCIe ID 16. It's the AMD's PCIe ID, and then 16E EF, I think, is the PCIe ID. It's their USB 4 controller. It's labeled AMD, but it can do PCIe tunneling, and you have the options now in the Agiza for PCIe tunneling. PCIe tunneling's Thunderbolt, basically. You can't call it Thunderbolt because Intel will come after you, but it is it's the open parts of the Thunderbolt protocol, which is PCIe over USB-C. And that's the tunneling part, is we're tunneling the PCIe protocol over that. That opens, that's all related to server technologies, like putting PCIe over things that it wasn't meant to go over. When CXL, it's like, oh, this is a PCIe slot. It's like, well, it's a CXL capable PCIe slot. It's not the same thing at the protocol level. So all this desktop server laptop stuff is all related when you're at that low of a level. And they enabled some Thunderbolt PCIe tunneling stuff in their chipset driver a couple of months ago, but it's nowhere near done. It's not done at all. I just got the minis for them, HX99G, which is based around the 6600M GPU, plus the 6900 XT. It's the 8-core, and it's 200 watts. They've pulled every lever to make it use as much power as possible and put good cooling on it. And it is breathtaking performance for a mobile chipset. It's like, dang, if you get a laptop based on this would be crazy. But
right, because with Phoenix, it's Zen 4 on 4 nanometer. I mean, this thing is going to blow Intel away.
Yeah, exactly.
8 versus 8 core performance at 25 watts or somewhere around there.
But the Thunderbolt part of it so far has been the most interesting aspect to me, because the Thunderbolt stuff is all there. All the plumbing is there, but everything is deliberately disabled in software, and they do everything they can to hide it from you. But it's all there. And I kind of was able to sort of force it to initialize at least, but the initialization stuff is turned off right now for some reason. So this thing has 2 USB-C ports that theoretically, maybe possibly someday, could enable PCIe, but the enablement, the bits that you need in the BIOS to do some stuff are gone. The platform stuff that you need is gone. The PCIe tunneling options are hidden. You have to unhide those. And I don't know why they would do that, because they demoed the PCIe functionality. I think HP demoed a laptop with that on AMD's chipset. And so little things like that make me think, is AMD facing some engineering bandwidth challenges? Yeah, it's like,
well, I think one thing to remember too, when we see how many design wins AMD gets with their mobile chips so far, is if you actually look it up, Raptor Lake it's been made since last year. It's drop-in compatible with Alder Lake. There's not a lot of work to get it into new laptops, and that's why they're in there now. Whereas AMD's Dragon Range, is a new thing. And even if Phoenix is compatible, if you look it up, they're actually not shipping it, I think, until March, which means the laptop designs won't be done until like April or May. And if you look at AMD's CES presentation, HP's like, we're going to have a lot of announcements in a few months.
Yeah.
And I think a lot of this looking at like AMD design wins right now is I don't think their laptop products are ready until Q2 anyways. And that's why OEMs are like, we're not talking about AMD yet because we got to get rid of Alder Lake, guys.
I've got a couple questions out to the Minis forum folks to ask them. So they had the HX9, or they had that HX90, which is the 5000 series. And my question to them was to ask them or their OEM, how much work went into retooling that for the 6000 series? Because if AMD has gone to their laptop partners and said, look, 5000 series is good, we're going to do a 1 2 3 cadence the same way that we do with everything else, because that seems to be what they do, is like a 1 2 3 1 2 3 1 2 3. And that could solve that problem if AMD is trying to set up the mobile swim lane to be the 1 2 3 swim lane, where they go to their hardware partners and like design a really kick-ass laptop, and we will make it super easy for you to drop in the 2 and the 3. You're going to do all the work. That's what I think they're
doing. Yeah.
So 1 is going to be a huge pain in the butt, and it's like, this isn't going to be available till March, and then we're not going to see laptops ship until back to school in August. That's 1. Then 2 is as soon as those chips won't even be, as soon as they come back from Germany, they're not even going to be cooled off. You could just solder them right into your laptop and it'll work. And will AMD be able to deliver on that from an engineering standpoint and be able to do that for 2nd and 3rd gen with minimal laptop revisions? And maybe that's why they're getting the plumbing in place for Thunderbolt, and why they're getting the plumbing in place for the mobile discrete GPU stuff being the way that it is, and the other internal stuff and power delivery and blah, blah, blah. So this would be 2 then, right? If it's 7000 series, or 3, I don't know.
I think this is possibly 3. I'm not sure, because I know, and here's the funny thing. I know that Navi 33, that they just announced, the 7600 MXT, that is 100% compatible apparently with the 700M and all of those, or no, 60, whatever Navi 23 was, those ones. I don't know laptop names that well. And like, to the point, same memory bus, power profile, amount of RAM chips. It's literally, if you have a 6000 series mid-range laptop, they want you to be able to just put the new one in, and it'll be cheaper too.
And it makes sense they would be doing this with DDR5. So they weren't able to quite pull this off with DDR4. So DDR5 is like, the 6000 is the first one we were able to do this.
Yes.
And so 1 2 3 1 2 3, and so
that's why 6000 had so many different designs, because they were new. It's new. They needed to make new designs for it. I think Phoenix is supposed to just drop in. And I don't know if Strix is 3. I actually think Strix may be starting over. At least it sounds very elaborate. Like there's 3 subgroups of it. It's got more tiles than Meteor Lake. It's like they're going for mobile performance with Strix big time. No more of this just 8 cores and we make the graphics better. Like, they're going for it. And I just wonder too if they're like, hey, we're not doing new designs this year because Strix is the big one. So why? And why bother? But at a minimum, if they're not doing that, you'd think their next acquisition should be some engineering company that can get someone to work with OEMs for you, because this is clearly a bottleneck.
Yeah, or just buy one of the OEMs that builds laptops. It's like, why? It's like, we don't want to get into that business. It's like, well, just buy a controlling stake in it or something.
Yeah. All right, so that's pretty much most of what I wanted to talk about here. If you've got the time, I've got a few more reader mails I'd throw your way.
Yeah, sure.
Okay, so Bacon House Collective writes in and says, when do you think project server-grade CPUs will break the 6 gigahertz clock speed barrier? With this in mind, do you feel we will still see a shrinking or widening in clock speed gap between server and consumer as nodes improve? I'm analyzing the future of cloud-based gaming models, and I wonder whether enthusiast market moves towards home do-it-yourself cloud-based gaming servers as a replacement for these services. So I think he's talking about how, like, in server, especially when we move to 3 and then 2 nanometer, we might see more clock speed regressions in these dense high core count server parts. And then it seems like at home, though, we're just all of a sudden we're at 6 gigahertz and we couldn't get past 4 for the longest time. Like, are we going to see more truncating in the types of programs we can even kind of do well from the cloud?
Yeah, well, if you have clock speed regressions in the cloud, you're going to get more done per clock. There will never be a performance regression. So it's like, yeah, you don't have a 6 gigahertz server part, but that's also maybe an indication of how unhealthy things are, or a portent of things to come, because we are seeing 4+ gigahertz server parts. Higher clock speeds, more silicon stress, more wear and tear, 24/7. Is it use, or has the quality control gotten to the point where it's like, oh yeah, no, this is totally fine? No. You read some of the reports coming out of Google, it's sort of horrifying. It's like, oh, we have individual cores that malfunction in a given CPU, and now we have to sort of track that. So I think server side for reliability, they're always going to be as conservative as they possibly can be with clock speed, and they will always design for power efficiency and the lowest possible clock they can get away with. And yeah, sure, there'll be applications that are poorly designed that don't scale well across cores, but that's neither here. And there'll be specialty applications that software licensing shenanigans drives too. It's like, we really do need an 8-core 5 gigahertz CPU because that's how things are licensed, is per core. But eventually the VMware drove some of that. They're like, oh, 64 cores, that's two CPUs. And it's like, well, what if what if I've got the 7713? That's not very fair, because the 7713 is not a super fast CPU. It's okay, but it's not the same as the 7763 or 7763X. And VMware is like, oops, that error is in our favor. It doesn't matter. It's like, come on now, guy. But
I was really disappointed when I saw that happen after Naples came out.
But 6 gigahertz at home, that's totally fine. And we don't care about 5 nines at home, and we want it to be as fast as possible, and blah blah blah. So that's fine. And then what was something about like cloud gaming? It's like, you can already cloud game if you use you can do DIY. Like, I do the Steam and home streaming with computers that are not in my home, and it is glorious.
Yeah, and I almost wonder if like what we're really going to see is like, it just matters if you care about the efficiency or not. Like, because I think there may be 2 versions of Zen 5, like one on N4X and one on N3, and they're like, yeah, this is the highest core count version. It goes to 3-4 gigahertz on server, and then it's literally the same architecture with half the cores per chiplet, and they go to 6 gigahertz. Because you guys don't care if this uses 200 watts at home.
Yeah.
That's kind of what I think they're going to start doing as some nodes become more dense and some become faster.
Yeah.
Chris Rich writes in and says, well, the MI300 is obviously a successor to the MI200 series. Might it be better thought of as a new parallel platform to EPYC? For example, the reference design that AMD showed had 3 sets of CDNA compute, 1 set of Zen 4 compute that had 24 cores. But based on what AMD has said before, they could just easily make a configuration with 4 sets of Zen 4 cores, giving it a total of 96, the same as Genoa, but with 128 gigabytes of HBM3 memory, paired the CXL-based memory. That could make for an interesting server for a number of scenarios. Do you see any other interesting uses for MI300 or the packaging technology behind it?
I think MI300 is, what I read into that is that AMD feels like they're very successful with their high performance compute supercomputers type customers, because those customers have already had that for a long time now.
Yeah, pretty much. Yeah.
And it's like, oh, MI300. And it's like, well, yeah, but okay, that's new. And the stuff it's being packaged into it is new, but the architecture is not new. And my read of it is that they were successful enough with that in Frontier and other supercomputers that they think they can commercialize it, which probably means that they're pretty successful with it. So the product that's launching is going to be a 2nd generation product, and I think that'll be really good. The last time I saw something like this happen was with Graviton, when nobody realizes it, but when Amazon launched Graviton, they had actually already been using Amazon for all of the services, not all the services, but a lot of the services that Amazon had. You can't tell what CPU you're running, where you're just like, give me a PostgreSQL instance, and then here's my URL and my port and my password and my other thing, and some of the microservices. They were running Graviton there for many, many years, and they used all of that data to figure out what they needed to put into the next generation of Graviton. And that was the first one where it's like, hey, look, we got ARM instances. Let's see how it works. And that's why everybody's mind was blown about how good it was, is because they dog-fooded their own product and put a lot of tweaks into it and made it really good. And I think that's what AMD has done with that packaging for MI300, and they've been dog-fooding it for like 5 years. And because of that, I expect it to be really, really, really good.
Mm-hmm. Robert S. Barnes writes in and says, "Hi guys, how close are we to a situation where we have a generic substrate and then can just order custom heterogeneous compute chips however we want on top of it? For example, I'd like 16 cores of Zen 4, I'd like 32 work groups of CDNA 3, an FPGA, and an AI inference accelerator, and 64 gigabytes of HBM3, please, all on the same substrate in the same socket. With the super APU that was shown off at CES, we seem pretty close to this. And this is something I keep wondering too, is when are we going to get to the hamburger future of AMD, where HP goes, you know what, our flagship R9s come with this unit, and we're actually going to have less cores, but double the gaming compute units. Like, how close are we to that for like server or for OEM customers?
I think Sci5 would like to add that guy to their mailing list. Because that's kind of the vision. I think that's my understanding. The vision for Sci5 and RISC-V is that you can do that kind of a la carte stuff and do your own thing. For everybody else, the market is what will have to drive that. And so game companies and other companies would have to present the use case for that. I don't think it'll come to fruition exactly that way. I think it'll be more the general architecture of the system sort of drives us that way as we bump into walls with the kinds of things that we can accelerate for computing, for games, lower latency, whatever we need to do for ray tracing. It's like, oh, well, we have ray tracing accelerators built into the CPU. Will we have ray tracing built into ABC XYZ? There's a from some of the people that have talked to me about their day job and how they work in the industry on these things, it seems like it's been happening for the last couple of years, is a revolution in tooling. Mm-hmm. Tooling to have better insight into what the heck the computer is doing, because there's so many moving parts, we've lost track of it all. There's so much that the operating system is responsible for. There's so much that the software is responsible for. Some of the software is happening on the CPU, on different cores. Multi-thread programming is hard. Some of it is happening on the GPU, blah, blah, blah. And so to directly attack the kinds of things that are contemplated by that question, I think that you have to have better tooling to have better insight into those things. And I think that because Intel's poor tooling is very poor, is why they needed so many steppings of Sapphire Rapids. And AMD's tooling... That's
true. And like Ponte Vecchio is so goddamn late, but it's because it's complicated, and then testing it and,
Yeah, and it's like you don't have tools to do all of that in an automated kind of a way. Meanwhile, it's like, there was that thing that came out that said, oh, AMD's using A0 stepping for their GPUs.
Well, that's the one that worked,
probably. And it's like, oh, that's why the thing. And it's like, how good is their tooling that they're able to do an A0 stepping? Meanwhile, Intel, by all accounts, world-leading technology person is doing...
Yeah, there's certainly two ways to make that argument. You could say, well, yeah, we made a working product that costs... And again, maybe it fell short of what they wanted, but at the end of the day, they have, with the 7900 XTX, something that costs less to make than the 4080 that competes with the 4080. So they were able to do that on A0, and it takes Intel 1,000 steppings to still lose a year late, so that's a good point. But you're right, like, to have custom chips, like, I know it on paper it sounds like, well, it's a hamburger, but it's like you'd still have to then put those chips together in this exact combination and make sure it works. Would more steppings be required? And you'd have to have such automated tooling to test out every combination anyways. And then I think there's like three ways to have custom chips. There's the super high volume way with like the PS5, where they're like, Sony's like, we'll pay the $10 million for the hard design for you to custom design this, man. It's worth the money. But then you have the really low volume custom chips like the Steam Deck, where it's not really a custom chip. They just have this design laying around and it happened to work for them. And then there's the middle where they like maybe disable things and stuff. I think you have to ask yourself, if HP wanted a custom SoC, can they not afford as much money as Sony to have it designed? Maybe not quite, but probably close that they could, actually. I don't know. And so this hamburger future would basically rely on customers like Razer and, not HP or Sony, but also bigger than Valve. To want to be able to custom order things that they probably could have just modified things on the shelf already cheaper.
It's at an event where a bunch of people were at, I got to ask one of the engineers, I won't tell you for which company, and I asked them, I was like, hey, has anybody tried just, when am I going to see a CPU or we don't even have memory. Like Apple's already putting the system memory on the package and it's not upgradable. Are we gonna see that in PC land? Like, am I gonna have? But is it gonna be like HBM or something that's actually really fast? Because I would love to have some terabyte per second HBM memory, like 64 gigabytes, and let's see if Windows still runs real slow with that. And he sort of leaned over and he said, "We already did that. It wasn't great." So, and I took away from that the software is just so awful and so unoptimized, and like dealing with that on the software side basically makes things like that untenable right now. That might not be true next year, and that might not be true 5 years from now, but right now the software is just god awful.
Well, so that's the interesting thing, though. I know I have to be very careful about this one. I know one company is working on this ability to have like gigabytes of cache on a chip, right? And I don't think I'm giving too much away by being that non-specific, because probably all of these companies are working on that. But like, it's that type of a thing. The way they do it's novel is really what it is. But isn't that like, if we could do that though, like, because I had on Dave Eggleston, who's like been a VP at Global Foundries and Micron, and he's a guy who's like a memory expert, and I'm like, isn't the holy grail like the PS5 made the SSD kind of act like RAM? Wouldn't the holy grail, even if it's expensive, be just like a terabyte of cache? No storage, no RAM. Programmers can be as lazy as they want. It's all coming out of cache anyways. Like, wouldn't trying to find a way to do that be the holy grail though, for like a next gen console that like skips several steps again?
In the specific case of cache, as the cache increases, so also is the latency. And so the latency increases even for the things that are relatively close. So you lose a lot of cycles for the quick things as well as the slow things. So it would be good if things didn't already have a level of optimization, but things already do have kind of a level of optimization, which helps a lot. And so, and that's why with the 3D Vcache on the 5000 series Ryzen, not everything benefited. Games were a large enough workload that they benefit, but a lot of other things had already been optimized for the available cache footprints, to the point that you didn't really see a benefit in anything that was two-dimensional, any even not just one-dimensional memory lookups, but two-dimensional memory lookups where you're accessing rows and columns. And that's, columns is fast in memory, but rows are slower. And with things like ANSYS and computational fluid dynamics and things like that, it's like a 3D matrix, like 3D particles and points, and it's a lot harder to predict algorithmically, and it's a lot harder to optimize for. And all of a sudden, having gobs of cache really helped with those workloads, which were even more on the spectrum of games than games themselves, because games had a lot more optimization than just random computational fluid dynamics stuff. So it's not the thing that's the holy grail is very fast, very low latency memory, because it's one source of truth. With cache, you have the coherency problem, and it's like, does this core have, this core changed something in memory? Did that even make its way back to memory yet from this other core that's accessing memory? It's like, so we have to build this whole coherency mechanism in place, and then CXL is another dimension of crazy on top of that, because something somewhere else could have changed something in memory, and it's like, now we need a protocol for dealing with that. And what do we do when do we have to go back in time, Marty McFly style, to make a correction and not interrupt the general computation of everything? And so there's a lot of hardcore computer science happening around those kinds of problems, and a lot of those problems just go away if you can just put everything closer together and have a single source of truth, and not actually cache everything, and not actually have 14 copies of whatever the thing is at 17 layers of cache. So you'd probably be right if everything lived in like L1 cache and that was all we had, but it's a little more difficult in practice because of subtleties and nuance and complexity.
That's kind of what Dave suggested as well, is like, I mean, you could do that, but it'd be expensive and that would slow down some things. So really, you probably just want like light speed L2 cache and then CXL and then a fast SSD, because it's probably not going to be any slower than a giant thing of L3 cache anyways.
Yeah. There's a lot of, and that's why I say, again, ARM is maybe a threat here, because x86 wasn't super well designed in the beginning, and it's been a 35-40 year compounding problem. And under the hood, it's like, oh, we got microcode and micro ops and blah blah blah. And Apple, for their M1, although it's just been incremental improvements so far in the M1, but the success that Apple has with the M1 is, I think, because the software and the hardware are really insanely tightly coupled. It's a team working together to do that really well. And that's the model I think that Intel's going for with one API. It's like, oh, we can do this, and it'll come together and it'll be really, really well. But so far, I'm not seeing really a level of success in that execution that rivals Apple's M1, if you will. There's a possibility
that's the
for
thing
that.
too, is Apple's working on server chips. They'll start by using them themselves, but they're working on them, and they'll start selling them to other people eventually if they want to. And when you look at AMD's comparisons, and I remember, I think I leaked that about a year ago, and now you're seeing it finally in the public things, is they compare their stuff to Apple, not Intel.
Yeah.
Because they do see Apple as, and maybe Grace Hopper as the real threat here, not Intel anymore. And that's a weird world to be in when we look at where we were just 5 years ago.
Yeah. It's really not like a whole other dimension you could go down, is like the Qualcomm Intel 5G lawsuit and the ARM intellectual property kind of at the center of that, and then what Intel's doing now with 5G and sort of trying to go their own way. And then it was and Apple, and how Apple was acting with Qualcomm and Intel modems in their phones is like, it was a level of malfeasance there, certainly, but it would have been cheaper for just Apple to just buy. They should have bought Qualcomm, or if there's no regulatory hurdles, so they could get by the regulatory hurdles, or some ARM company, or a combination of them to do all of that. It would have been a lot simpler. I think looking back, if they knew then what they know now, they probably would have done that. But too late now.
Well, yeah, I mean, I think if Intel knew what they know now back then, they would not have spent $7 billion on McAfee, and they would have put all of that money into the 10 nanometer node.
yeah. There's stuff like that. That's just, it's like, what are you guys thinking? Who made this decision and why? This makes no sense. It's like, oh, this paper.
The answer is usually Murthy, from what I hear. He's the one who made that decision, and he doesn't work there anymore. So,
craziness. Yeah, Pat Gelsinger's got his work cut out for him. Pat Gelsinger should make sure that he knows the Netflix Accelerator story, and they are poised not to repeat that, because they could be setting themselves up for an unhappy time with their Accelerator ploy.
Yeah, I mean, people love Pat at Intel, and like, they only say good things for the most part, but they do say maybe he was a little cocky when he took over and thought they would come back faster than they have. But from what I'm hearing now, he's making the right decisions. It just depends. It's all inertia. Does AMD have the right inertia? Is Intel's inertia working backwards to the point that by the time they move it back up, I think it passed the right guy for the job. It's just, I think it's a much scarier thing if Intel doesn't do well over the next few years, because I've heard people say, well, maybe Pat isn't, what they needed, but because everyone he says he is, it's like, well, that means that no one's good at it, fixing Intel if he's not.
Yeah.
I don't know, though.
Yeah.
We're going to find out, I think, within about, this is 2024 is do or die for Intel. That's what it's going to, which means really this year is, because everything in 2024 is being finalized this year.
Yeah. I think Pat Gelsinger is the right person for the job, and he can certainly get Intel there, but you have to see the kind of problems that they had with Sapphire Rapids launch. It takes a long time to make changes that correct those kinds of issues. And I don't know that they have that kind of time left before AMD gets to 50% market share. And they don't,
exactly.
There's not a lot of, they pulled out all the stops with pricing and products and blah, blah, blah. There's probably somebody sitting inside AMD that says, well, we don't even have to be interested in this market. As long as Intel is hemorrhaging money here, we'll just continue to let them hemorrhage money while we focus on this thing over here.
Well, that I think a lot of people, because I made a video, I think one of my first videos to get like 50,000 views or something, was in 2019, where I said Intel isn't too big to fail, and I made it so clear at multiple points. I'm not saying they will. I'm not saying
they got a lot
will.
of cash, and they don't have a lot of debt.
But the thing is, I didn't think they'd run out of money this soon, and now I'm like sitting in a place where I'm like, they're not going to go out of business, guys. Of course not. But it's like, are they at? It almost feels like they might already be past the pricing singularity, where AMD is making more money per product, and they're so big that they aren't bringing in enough revenue, where I'm not saying they'll go out of business, but I am genuinely worried now that they're at this like losing thing where they're unavoidably going to become smaller. I don't think we're there yet, but I think in the next 2 years we're going to find out if that's possible.
It's I think historians are going to look back at probably from the late 90s and on with Intel as, you know, we sort of look at Xerox, and it's like Xerox really fumbled because they created the Palo Alto research lab, and they employed like 13 people there, and then they fired all those people because they didn't want to accelerate the paperless office. But those people were like, this is an existential threat to Xerox, and we're gonna do this. And we talk about how dumb that was. And Intel was in a position to completely take over mobile computing. And the reason that they couldn't is power efficiency. And so they failed to do anything there. Intel was in a position to completely take over mobile and laptop computing. And again, they failed because the power efficiency got to a breaking point with one of their largest partners, Apple. And that was sort of the blood in the water, like, oh my gosh, something is wrong here. And almost simultaneously, you have AMD nipping at their heels in server, desktop, you know, everything else. And then all of a sudden, plucky little AMD with a tenth of the resources and people has come out with, you know, designs, and they put an all-star team together to come out with all this stuff. And it's like Intel fumbled it again. And then you have Mobileye, which is actually doing pretty good, and 5G fumbled hardcore, and all of these other offshoots. Edison canceled. Optane completely changed the game for storage and latency, fumbled, dead. Arc, the jury's still out on Arc.
AXG is dead. We'll see if Arc is, right?
Yeah, and so it's like, again, it's mind-blowing because there are aspects of that technology that are legit awesome. There are aspects of one API that are legit awesome. SPDK in its own right is legit awesome, but fumbles. And so it is if you're going to fail, you got to fail fast. And all of these failures have not failed fast, and that is what is going to bleed them dry.
Well, and I wonder, and granted, you could point to other things. There's always multiple things you can point to, but when I look at like the amount of money AXG wasted them over 4 years, pretty much actually.
But see, they came up with things that could have been profitable and awesome
if they had the money to back everything at once. But if they use that money on everything else, then make Arc, then do it. Do it after this other stuff is winning.
Yeah.
You know, it's like, and maybe Arc was just like 2 years too soon. Like, that's honestly what I'm starting to think. Or 2 years too late. They had all the money.
Yeah.
Would have been great to start that around Broadwell, you know, when AMD was almost out of business. That would have been the time to do it.
Well, if you want to take it to a metagame, Intel fumbled the entire Nvidia market cap because AI and accelerators for that kind of thing, because Intel totally saw the writing on the wall with vector accelerators in the Itanium, and they fumbled it. They fumbled it real bad, and then they were just like, well, I guess we won't do that. And then they did Larrabee, and Larrabee was great. Larrabee was an incredibly insane x86 design, and they looked at what John Carmack did with Doom and Quake, and they built the thing to make John Carmack's brain run insanely fast. The problem is that nobody else had John Carmack's brain, and so it didn't help anybody except John Carmack, and so it wasn't adopted by anybody. And again, it's like, oh, just call me fumbles. But it was like Larrabee was legit incredible, but you have to have John Carmack's intelligence in order to appreciate how insanely incredible it was. And so nobody wanted to touch it with a 10-foot pole. Maybe rightly so, because it was different than everything else. It was, where are you going to hire people that have experience working on that thing, given that it wasn't the first mover in the industry? But Intel could have been the first mover, for that kind of thing. Intel could have been the first mover for AI. They could have been the first mover for foundries that are power focused or power first for mobile and everything else.
Well, I think they might be. That's the funny thing I'm learning is if there's one thing that may survive, it's their foundries, actually. and that's what's so interesting here is like, I mean, it will be truly interesting if in like 5 years we have like Intel 12A and it's making Zen 7 and I don't know what comes after Diamond Rapids, right? But, you know, something like that. And that, I mean, that I think Pat at least knows that's such an asset to them to have this capacity in the West as well, that he's thrown all of the money at it. But now that the foundry's working, where are the designs? You know, and it's just
it's the aforementioned tooling is missing because you want to be able to submit a design and be reasonably confident that the design has been simulated to the nth degree and is really awesome and ready to go. And that wasn't even how the process worked with the foundry, as we were kind of discussing. And so that change is also probably going to hurt their inertia in the short term. But in the long term, it'll be really good for them because that's how everybody else does it.
Again, these 2 years, if they get through these 2 years, Intel has so many things they're working on that are awesome. It's just like, just cut the things you can that you need to, because you got to get through these 2 years though, because it's looking scary. And I'm just I'm so surprised that we got to this place though, where I can actually see it, you know, like the writing on the wall. Like it's crazy. Yeah, it's interesting times. And I'm excited to talk these interesting times with you every time you come on Broken Silicon. But I've had you for over 2 hours. I think this is a good place to wrap up kind of this future looking conversation we just had. Is there anything else you wanted to discuss or you want to say before we wrap this up?
No, although it has been a very long time since I've seen this much innovation in server and desktop, especially, maybe mobile to a lesser extent. But like things are moving real fast in server on the hardware and the software side and accelerators. And there's a lot of people looking at stuff, a lot more people than historically there's ever been looking at stuff and saying, gosh, we could probably do this thing to make this faster with networking and communications and accelerators and DPUs. And that's really, really exciting because all of those things will sort of change the future. And also AI is probably like some sort of AI revolution is probably right around the corner. It's probably going to come way sooner than anybody expects. And I'm not saying like Chat GPT is going to become sentient or anything. I don't think that's
no.
I don't think that's going to happen. But
look at the AI engine in Phoenix. You could see a thing where like not every task, but half of the tasks you do on your laptop, it uses a neural engine to use zero energy to get it done, and that doubles your battery life depending on what you do.
Yeah. It's the future. The future from a computing and technology standpoint looks really amazing, even if macroeconomic conditions and joblessness and everything else, that doesn't look good. But I've never seen this much innovation in the space, and that's really exciting.
I know, and that's why I think anytime you see people disappointed with a product launch from any of these companies, I still go, because every now and then I'll see a comment like, well, this is such a weak uplift. I'm like, well, okay, first of all,
in my day, we were lucky to have working floating point.
It's like, no, this uplift is huge though. Like it's, and even with these companies fumbling every now and then, let's not forget that we've gotten used to them because of chiplets, because of actually writing good software now, sometimes because of accelerators. We are still seeing, we didn't get like 10% boosts every year just 5 years ago. And now we're getting way above that, even if they fall short sometimes. So.
Yeah. It really is not. And that we're able to get these kinds of gains at such small lithographies, because, you know, for the better part of 10 years, everybody's been saying, we're basically at the limit of the laws of physics. And you think, you know, in 1/5 billionth of a second, you know, 1 5 gigahertz clock tick, this light can travel about this far, this distance between my fingers here. That's 1/5 billionth of a second. Light can go, bloop. And that is mind-blowing, because that's the fastest thing there is. We don't know of anything that's faster than the speed of light. And light,
like, we're getting bottlenecked by that now.
Light can only go this far, and like the silicon and the transistor settling time is orders of magnitude worse than that. So like if we can figure out transistor settling time or go to purely optical interconnects, we're going to be in much better shape. But this making things out of silicon, that's a real problem.
Yeah. Well, but we have go this far. Right. But what if we then reduce some of the stuff up here, with 3D stacking, then we can cut that down a bit more.
Was it, I don't know if this is true or not. For some reason, out of the back of my head, I'm sort of remembering that if you took all the wiring out of a modern processor, you could go from the surface of the Earth to the moon and back like 5 or 6 times, something like that, just in one processor.
I don't know that, but a crazy thing I heard from John Petty, who was on less than a year ago, he said they don't actually know how many transistors are in graphics cards anymore because they have different IP block teams, and they're like, this is about this many billion. And then they add it all up. And so when you see like the 4090, whatever it is, right, 60, 70 or something billion transistors, they're like, that's an estimate. These chips have gotten so complicated. They actually don't know how many transistors they have exactly.
Pretty soon it's going to be atoms per transistor.
Yeah.
Which is still insane. But, well, thank you for having me. It's been a blast.
Well, and tell people where they can find you.
Oh, yeah. Level1Techs. You can just Google Level1Techs. You can find me on Twitter or on YouTube, or we have forum.level1techs.com. Come hang out, whatever. It's fine. Or don't. It's fine that.
Or don't, but if they do want to, there will be links in the description for that. And, to everyone else, thanks for listening or watching Broken Silicon. Remember, you can subscribe to us on podcast apps, and give us a review in addition to subscribing on YouTube. There's a Patreon that's the last guest questions, gets it early ad free, a bunch of other content as well. And thanks for watching and thanks for listening, everybody.
Thank you.
This podcast was brought to you by the YouTube channel and website Moore's Law is Dead. Moore's Law is Dead and Broken Silicon are trademarks of their creator, Tom. That guy is me, and I am indeed the creator, editor, writer, and showrunner of Moore's Law is Dead podcasts, videos, articles, and other media. However, it's not just me. Moore's Law is Dead is a team, with Broken Silicon co-hosted by my brother Dan, audio editing by Gerard Cortez, renders being done by the industrial designer Jean-Philippe Clermont, and special assistance is also provided by Carmen Cry and Carrie No Sugata as well. Find all of our information at www.mooreslawsdead.com on the about/support page. In the event you do want to hire me for consulting work, hire Gerard for audio work, hire Jean-Philippe for industrial design work, or you're interested in working with Carbon Cry or Carrie No Sugata as well. You can also find our long-term sponsors on that page if you want to show them some love for putting food on our tables. Or you can also mail us some love. You can send letters or hardware donations to the following address: Moore's Law is Dead, P.O. Box 60632 in Nashville, Tennessee, zip code 37206. Although, to be honest, the best way to show Moore's Law is Dead some love is to support us on Patreon. Patrons are what makes Moore's Law is Dead content truly possible. Every month, and really every day, depending on who you're talking about, me, Gerard, Dan, and Jean-Philippe are working tirelessly to provide a steady stream of content that we could not keep doing unless we knew the work was possible without being reliant on sponsors dictating every little thing we put out. Don't get us wrong. We love our sponsors, but we love directly working for you, our fans, much more. If you have any extra money, even a couple free dollars a month, consider supporting us directly on Patreon. Those couple of monthly dollars will get you access to the exclusive podcast Die Shrink, voting on subjects of future podcast episodes, the ability to ask guest questions, and of course, access to the Moore's Law is Dead Discord full of like-minded people who I am sure would love to meet you. I am one of them. Additionally, higher tiers get access to early, ad-free episodes of Broken Silicon, the ability to ask questions in all Broken Silicon episodes and Loose Ends live streams ahead of the recording, and the entire back catalog of Moore's Law is Dead podcasts, in addition to having thanks in the credits of videos and podcasts depending on the tier, with other perks available as well. And hey, if you cannot afford to support us directly every month, please do share Moore's Law is Dead videos and podcasts with friends and family, and on social media and websites like Reddit, and give Broken Silicon a 5-star review on Apple Podcasts or your preferred podcast app of choice. All of this does really help us so much. But like I said, this podcast would not be possible without the patrons directly providing predictable and reliable support every month. And so now it is time to give a personal thanks to the greatest of the fans. The following supporters are at the 10 gigahertz or higher supported levels: Brad Medlin, Drita Full, AV, Anthony Greffa, Greg Bataki, Muhammad Akwari, Brett Jones, Aaron Close, Little Germany, Jan Rauner, Daniel Hyde, Shredbird, Brian Riggleman, Dr. Forbin, Sam Miller, Deke, Josh Law, The Mechanical Philosopher, Terrence Harrod, SNES Chalmers, Tom Bailey, Greg T. Wanchik, Andrew S., Frank Zielinski, Daniel D., MJB1, Eric Jackson, Justice Brennan, Sammy Good, Valco Malev, The Boss Haas, Nicholas Buckner, Spamtum G. Spamtum, Jonathan, Lord Starstream, General Drips, Blake, Fagro Frederic, Matthew Lazier, Jensen Wang, Nathan Mose, Aziris, Gregory S. Ecker, Dominic Koch, Jake Dude 23, Jake Martin, Cameron, Christian Lavoie, HeartForum.com, Original Ross, Licky, Lance Bassler, David Cowden, Ricky Tan, Christopher A. Butler, Jeezy Ziggy, Star Castro, Stephen Hart, David Sebastian, Meat and Pork, Stu, Tim Robb, Luis Correa, Ian Clifford, Jesse Jeskowiak, Travis Gooding, Holden Mobley, Nanny and Chris Rich, Deepest Learners, Mad, Zootsuit Taylor, Stephen Coates, Michael McGee, Chuck Glidden, Sammy Malas, Greg, AWS Danny, Patrick Groh, Amiable Chief, Brett Summers, Milton, Stephen Dick, Tommy, Kundin Brucha, Mark Mitchell, Mac Daffy, Delmain Peterson, James Anderson, Marshall Pierce, Mark Raidmaker, Dave Schultz, 3DS Boy 08, Halbuma, Norithio, Matthew Landavazo, Stefan Koladik, Henry Zhang, Judson N, Keith Moore, The Grid, Michelle Pell, D31337 Antics, Joseph Kelly, Noah Nicoella, Hexapuma, Chrysantine, Jim Ferreira, Mayor, Keith Moore, Kita, Abdul Kadar, Precision, DNA Tech, Radiant Technologies Group, John O'Shea, Royce Meyer, Charles Russell, Reginald Ari, Slushbot, Tika Autumn, Jackson Miller, JSMMH, Neith Razink, Mean Dean, Cal, Andre Jacques, Game and Since Reagan, Jeff Settler, Jordan Simkovic, Loophole 35, Winstar, William Welpe, James I, Raider, Corey Leonard, Nell Lima, John Shin, Justin Bussell, Kelfin, Austin Haggerty, Roger Davies, Shay, William Leaked, Corey Chappelle, Evan Dingle, C2, John Iverson, Samuel Park, Aaron, The Eternal Dreamers, Jansen Ngima, Mark Central, Derek Lambine, Michael Fours and Pours, Him, Sagung, RB Racer, Space Channel 5, Jay Terrino, and of course, thank you to Sahara for the music.